hello to whoever is watching. It's an early morning, well, not too early, but relatively early morning stream. Uh, so probably a few people did not expect me to do this. So, yeah. In any case, let's do some work. I have stuff to do. Okay, so yesterday we were looking at this, and the question, although, you know what? We implemented resize, but not fully. We have to do better than this. Okay, let's retrace our steps. So resize computes in one pass the old size and what the new size needs to be. Yeah. Okay, so this is fine. The problem is, so we do the computation, then we're copying everything, but no. So we need this. Like this. So we have the original. We save a copy of the original struct that contains the original lengths of everything. Then when we do the remap stuff, this is the easier case where the remap fails. If the remap fails, then in here we can copy this stuff from P basically. We don't need copy. This can be P. Remap failed, do everything manually. Unlock with options, make a new one. Set new to P. And then we need to rewrite the tails. And we do that based on the offsets in original. So how does it work? Hello, proper bug. So I'm completing the resize implementation for our heap arrays with tails. And we need to move the tails forward. So it's a mem copy forward, that's for sure. And it's basically from the old asset, from the old offset to the new one. You know what? We might as well save deltas somewhere. Yeah, I started streaming way earlier today, about 6 hours earlier compared to when I normally start. Yes. Hello, Low Bite Fox. Hello. Hmm. deltas. We actually, I would say that actually we wouldn't mind when we compute this stuff, we would be able to do deltas. I need to make something with in Zig again, just kind of stuck with C3 for now. What do you mean by kind of stuck? As in you're using it, but then right now you don't know what to do, or with it, I mean, or what? Using C3 for most of my stuff. Hello, Infinity Coder. I think we need to make some kind of stack that we push to and we pop from. Hello, Mycon. We need to make a stack. We need a stack, a tiny stack, not a huge one. We need a tiny stack in here. Every time that we scan a field, we write down what the original offset was, what the new one is going to be, and then we pop from this stack at the end. And as we do that, we do a mem copy forward. Starting from the last element that needs to be moved forward to then everything else. Yeah. That should work. Hey, Crypto Code. Good morning. Yes, early Z stream. Fresh in the morning. Thinking about resizing resizing buffers on the heap. It's like I don't know, doing actual real work. So we need an array list based on a fixed size buffer. How do we do this? So I guess var buff is going to be an array of you look partly Indian. Sorry to disappoint. I don't have a single Indian gene in me, or rather, I don't know. Maybe I do have some, but it's not going to be a big percentage. What you're zeroing in is actually Central American genes, which guess it's Indian, but not in that sense. But you're not the first person to point this out. Mm, okay, so let's not waste space. So this can be like this: extract old, new. Actually, we don't need an instance of this thing. It's just this. It's just the type. Yeah. I think I know who you're talking about. Um. Do-do-do-do-doom. The overview. Yes, I implemented yesterday. So the idea is this: the Radix 3 data structure um, needs you to be able to resize. It needs you to be able to resize nodes in the data structure. So these nodes are heap allocated memory, and the problem is that, well, we need to implement resizing, and resizing means not only, well, changing the size of the allocated memory, but for example, when you grow, you need to then take the old data and shift it forward, because when you're growing, you could be growing, for example, the very end of the tail. So in theory, nothing needs to be moved, but you might be growing a part in the middle that might be your intent. So when you have one single allocation and your intent is to make more space for more data that sits in the middle, then what you have to do is grow the allocation, which we have done implemented yesterday, but then you need to take what the end of the data and move it forward so that you can actually have space for more data in the center. And that's what I'm implementing. So basically here I'm saving the old size of a thing and then the new size of that thing. And then after I'm done resizing, I need to shift things forward basically, or backwards if you are compressing. Hello, Andrew. Yeah, I'm early today. So we can do these. I guess we can do buff IDX. Deltas IDX. I think this is not bad. We can put a comma in here. Let's see. Can you create an array list of array lists? Sure. I would say, generally speaking, is not a great idea. If I were to see some code that does that, I would question if it's really necessary. But you can totally do it. And there might be some use case where it's actually the right thing to do. What happens if you don't have space backwards? If you move the full block to another place? If you don't have space backwards. I don't know. Multidimensional arrays. Usually multidimensional arrays are not done that way. You have something already on the memory. What happens is that you basically, if you can't grow, then what you do is that you create a new allocation with the new size, you copy everything over, and then you free the old one. Which is actually what you see me do here. I try to do remap. If remap doesn't work, then we literally make a new one, copy stuff over. This is missing some logic, and then free the old one. Okay, we will encounter a flexible field. We encounter a flexible field. Where it's the starting point of that field? It's this guy. We set old size. Wait, what the fuck am I doing? Oh no. Oh no. This is right. This does forward alignment. Okay. Yes. Okay, that works. So here we can say that deltas at let's call it dix di. Delta says delta's index dot old equals old size. So this is where we start copying. Although, wait a second, this is the start. It doesn't know the length. So it's not really. It's the offset. Well, it works. Okay, so old position. This is the old position. And then we don't care about the length because we have that information. We don't need to store it. Well, no, wait. Wait a second. I think maybe we should also do len. Honestly, that does not hurt. Length, old offset, and new offset. Yeah. Yep. Then we care about the new length. Yeah. New length, new length, new length, new length. This is the new field length. But we don't care about that. We care about the new offset. Is this it? Yeah, this is actually it. Okay, this should be everything we need to keep around. And then what we should do. Let me think about it for a second. Actually, we should do it like this. Invalid left hand side to assignment. What do you think of function calls that look like the following? Save position, allocation, x is v dot left, y is v dot right. I don't know. What exactly is your question? Like, if I think that there's anything weird with this function call? No? That seems. Oh no, I think I understand your point. Wait, I now see it. Is the x colon, y colon. So you're talking about um having like named parameters. Is that your point? If you want to have named parameters in Zig, you can accept a struct. Whenever you want named parameters, have your function accept a struct, and that way you will force the extra clarity on your callers. Let me see if I can give you an example. Um, I'm thinking of a good one. Debug allocator. But that's true, but that's a generic thing more than a normal function call. I was hoping to find a normal function call to showcase. Well, here's okay. You know what? If it's generic stuff, then take a look at this. Um, here I created this thing called a flexible array. And a flexible array, in this case, it's a generic function, but that's a detail that is not super important. The point is, I want people to specify options, and I want them to be explicit. Like I want them to write down what the field is supposed to mean, etc. And so I create a struct named options, and I have this function accept those options. And so usage looks like this. Flexible array, you have one positional argument or multiple positional arguments if you want. And then we have this trailing trailing struct that you pass in. And it's not bad. If it, like, obviously, you can use whatever order you want. But if you especially accept first all the positional arguments and then you accept a struct last, it looks particularly cool, in my opinion. And you can see that here we have full clarity. You have to say parent, you have to say name, you have to say length type. So, long story short, this syntax here, it wouldn't be necessarily bad, but look at how many language features you actually don't need to have to still be able to obtain the same overall effect. And I think that's kind of cool if you think about it. Because, like, think about Python. What does that language feature, like named fields, imply at the language level? I don't know why this stupid browser decided to not play this anymore. Sorry? Hello? Okay, this thing pooped itself. So, yeah, keep that in mind. So, well, okay, Python, I was saying. Yeah, think about Python. So you have positional arguments, then you have named arguments, then you have the star argument, right? You remember that you have to do, when you define a function, def fun, then you do A, B, C, and then you do star to force foo and bar to be passed in as named parameter. So this way people cannot use positional syntax for foo and bar. And then there's more, right? There's so like, what the fuck does it mean passing a star? It's not even that. You know what? It could be worse syntax. I don't personally actually really hate this, but it's kind of wonky. I think there's more than this, right? I think there's also, is it, am I misremembering, or there's also a slash, although I don't remember what it does. I remember that star separates positional arguments from named arguments. Is the slash something that forces you to use positional syntax for these guys? Because I remember that the star stops you from using positional syntax for these guys, but it doesn't stop you from using named syntax for these ones. And then you also have args and quargs, which is kind of funny. This is another piece of complexity. Yeah, you wouldn't need quargs. You would only need args if you didn't have this distinction at the function syntax call. So, it's not necessarily a bad idea. The point is, it's ultimately you have structs, which is cool. I think more of Yact as an example. When you have a variable that is not named in the same name as the parent scope, you need to use a named parameter. In the parent scope, you mean in the caller, because usually the parent scope it's lexical stuff. So, for example, this is a scope. Well, it goes down, or you know what? This is a scope. This is an internal scope inside this if, and this is the parent scope, and this is the parent scope of this scope. So I'm guessing you're saying that if when you call a function, your variable has a different name than what the variable is, what the parameter is named, then you have to use a name parameter. and you don't otherwise. Understood. I don't think it's a bad idea. I think it's a good idea. I like it. Zig doesn't do it. Zig could if he wanted, but it doesn't. And it's not a fully inconsequential decision, because if you want to implement this, then you have to track that information, which means that you need your intermediate representations need to have knowledge of those names. And in the case of Zig, we don't. So you do get some savings by not having to track this. And it may seem small stuff, and it is small stuff, but if your project is big enough, it becomes significant. Now, I'm not saying that it's significant enough that everybody should do what Zig does. Not at all. What I'm saying is, I see the value of this feature. I think that I'm fine with not having it, but it's not one of those cases where, well, it doesn't cost you anything to have it. There is a cost associated. Not a huge one, maybe, but there is some. How can someone move into and get better at system level programming? You know what? I have the perfect answer. Well, no, I don't. But but I just so happened to have given a talk on that subject, and my recommendation is to check it out, because well, but what I sent, I think the last time I answered something similar, it wasn't specifically about like how to get better system, how to get started with systems programming. It was more about like how do I get started specifically with Zig. So I see them as different questions, like getting started specifically with Zig versus getting started with systems programming more in general. So this is my answer. And I would say maybe Mr. MLX, if you end up watching it, then after that, if you have any follow-up question, I'm happy to basically continue, I guess, the discussion from where that talk ends, which is like, for example, I don't give tactical advice in that talk. Like I don't tell you, so here's the first thing, second thing, third thing that you should do. I just give you a high level answer. But if you end up like I don't know, if that talk makes sense to you, then we can talk about specifics afterwards. Ba-ba-ba-ba-bum. What was I doing that oh yeah, we were talking about stuff. Okay, so the actual work is here. Deltas, the I have this if that for some reason invalid left hand side to assignment. But is this just ZLS going insane, or is this really an actual problem? It is. Bro, this is cringe. Oh, because the if binds tighter than this? Really? Huh? Expected parentheses found plus equals. So what's happening is that Z thinks that this is. When did this change? This used to work, man. Well, I guess we can do this, but cringe. Yeah, you can do that, but I don't want to do that. I wanted to put everything on a single line. God damn it. I wanted to put everything on a single line. Okay. So with this, let me double check briefly the logic. Um, well, I mean, to be honest, you know what? This is dumb. We don't have to do this because, oh no, we have to do this because if this is void, if this is void, yeah, never mind. Yeah, and this reminds me that we actually also need to worry about this case. Okay, let's see how it goes. Um, okay, so in theory, I have done all the counts, and then the next thing that we want to do um is apply them in reverse. So, you know what? I'll be right back. Just give me a sec. Okay, I'm back. We were saying, so we have the old offset, new offset length. Wait, really? Yeah, okay. Okay. Then we still have the original that we don't touch. No. Okay, so let's do the remap case. So we now have more information. Hello, Caritam. Good morning. So we copy over the struct. Then we need to shift everything downwards, let's say. So I guess we start from... Should we go backwards? Should this be the I equals deltas.len? I think we should start from there and then we'll go backwards. Yeah. Okay, so in here we can say for deltas di dot dot. Yes, I'm adding resize. So you have a struct with some tails, you resize it, and then maybe your intent was to resize like a middle one to make more space for new elements. So everything that's after needs to be shifted right. So that's what we're implementing. And once this is implemented, then we will have implemented this correctly. And so we can move on. We will continue the Rax implementation. So for each delta, here what we do is, this is a normal mem copy because there's not going to be any overlap. So we can add mem copy. So we can add mem copy. I missed the part where you explain what the point of flexible array was. It's this idea. So I'm gonna share with you a link. You can check it out, and then if it does not make sense to you, then we can talk about it. Flexible array member. It's like it's a C concept. This is the idea. I'm making basically this, but it is that you can have more than one, and the ones in the center. So the one, all except the last one, they do keep around a counter of their own length that they manage, let's say, individually. But then you can have a tail one that doesn't have that information stored anywhere, and you're because the assumption is that you're deriving it from somewhere else if you want to. In any case, sorry, to start reading that, and then I can give you a more specific example of what I'm using that for. So we can mem copy, but this len needs to be, yeah, len needs to be com size. Where did I go? Actually, it's old size basically. Oh, it's this. There we go. Okay, and then when we go here, when we mem copy, Actually, we don't even need curlies, I think. We mem copy bytes at old offset dot old size to, oh, this is the destination. So this is the source. And the destination is data new offset dot. The trailing command is not bad. We mem copy as new offset the old stuff. So this is perfect. And then we do this, and it should be not a problem. Actually, in this case, the order doesn't matter. But in this other case here, it does matter. So here we either remapped or we std mem copy forwards, copy forwards. Copy all the source into destination position 0. Then must be destination must be greater or equal to the slice. Yep. If the slices overlap, destination pointer, oh, must be lower than source pointer. Bro, why are you not asserting this? Oh no, where's the assert? This needs an assert. So it's like an array with a size. I would say that the point is that you have a struct, and your struct has an associated array. It could be more than one, but let's start with the idea that it has one associated array. So the silly way of doing, well, the vanilla way of doing this would be that you make food. It's your struct, and it has a couple fields, something like that, and then it has like the data, which is variable length. So normally you do a slice of const. I don't know. Let's say that it's like U32s. This is the data. It's a bunch of U32s that can vary in size. And then somewhere else, right? You basically do data equals GPA dot alloc 20, sorry, U32 and 20, 30 of those, whatever, and then you do, um, let's say that you put foo. Let's say that you also put foo on the heap, so you do foo equals GPA dot create foo, and then you do foo dot star equals to a equals 1, b equals true, and then you do dots, and then you do data equals dots equals data. So this works. You can do this. Now you have on the heap, you have one struct that lives here, your buffer of data that lives here, and a pointer that connects to them, which is the slice. But if these guys have a one-to-one relationship and they always leave one connected to the other, a more efficient way is to get rid of this pointer, reduce all these two allocations to one, and have one contiguous chunk of memory that has the struct at the beginning that acts like an header, and then a tail of bytes that then you use for basically this, except that it can't be a slice anymore because a slice has a pointer. I guess you could make it point to itself, but you don't want to waste memory to store a pointer that you don't need. So this is what a flexible array member is in C. In C, it's in C you basically this is in the C syntax. The tailing thing is not a slice. It's a special way of saying data is a pointer to the end of the struct, and then it's entirely up to you what's after and how to interpret it. In Zig, we don't have this language feature, but you can get that with metaprogramming, which is what I was doing. So in my case, let's talk about a concrete use case, Rax. In Rax, this is how it works. A node struct has a layout enum, a bunch of flexible arrays. Let's ignore these ones for a moment. Imagine that we also have other features. And then there's the last thing here, which is a flexible array member of length type void. We don't even store the length. To see what this is supposed to be in practice, you can take a look at this. You check out the README. In the README of anti-res Rax, there's an explanation of how these in-memory nodes are structured. Well, I guess I can open that in another tab, can I? Let's go back to the top. Here you can see that this is the idea. Header is the struct, and then there's a bunch of tail data with variable lengths. And again, header doesn't point at those. You use math to get to those guys, because you know that they are past the end of the struct. And then if the struct remembers the length of all these sections, then you can use, again, you multiply, you do a bunch of multiplies and adds, and then you can boop, 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 go forward. That's the general idea. So we don't want copy forwards. Oh, sorry, we want copy backwards. This guy does the insertion. God damn it, this one does not. This one should. Wait, copy backwards? Destination length must be greater than or equal than source length? Is this wrong? Here we are asserting it. Add runtime safety false. But then there's an assert. What is going on with this code? So is this like a weird way of saying just do this in debug? Why is this not just doing that? Oh, this function is deprecated. This function is deprecated. Use mem move instead. Oh, that's why they suck, because they're supposed to be deleted. Cool. Let's use mem move. Yeah. Okay, what do we know about mem move? Destination source. This function copies bytes from one region of memory to another, but unlike mem copy, the regions may overlap. Destination must be a mutable slice, immutable pointer to an array, or immutable many item pointer. Yeah. So this is memory implementation of what's usually disk implementations. Maybe. Maybe, because I know that there's a bunch of trees that get used for file systems. Sure. Do Radix trees get used for disk stuff? Maybe. I'm not sure. It would make sense to do that, I guess. So I would not be horribly surprised if that's the case. But I think that every time I see something about file systems, it's usually what, like, I don't know, red black trees, maybe some kind of stuff like that. So maybe, I don't know, but you can definitely, it's common to have Radix trees in memory, because they are decent ways of implementing, like dictionaries, where there's a lot of overlap and you don't want to store, a ton of duplicated data. Radix trees are decent at deduplicating. They don't deduplicate everything maximally, but they deduplicate reasonably enough, let's say. Especially when things have a common prefixes. Like, that's kind of the point of a Radix tree. Deduplicating prefixes. It doesn't just do that, but that's like the general gist. Okay, so here we can do mem copy because we know that these are two separate allocations. Here we have to do mem move because it might be that bytes, the original stuff, has been moved over. But yeah, in any case, it has to be done on new. And this order is important in this case. If new the pointer equals bytes, return null. Otherwise, we need to return the new pointer. Okay, so we return the new pointer. Oh, which is not this. Return at pointer cast new.ptr. There you go. This is good. Good primitives. Holy shit. Really good primitives. This was a breeze actually to make. I mean, maybe there's some bug that I left in the math, but this was cool. Original. Oh shit. Why did I think I needed original? Oh, I know. The fur. P.star equals original. So here's what happens. As we do the math, we modify everything to, well, do I need all of original then? I actually don't need that. Okay. I don't need this. On RDFR, I just need to reapply the deltas. Oh, but I lost information of which fields are those. You know what? Fuck it. Let's do this. Just a copy of it, and on RDFR we restore it. This could be made more efficient. But I guess it's fine if it's not. Okay, let's see. Here there's a try which might fail. So we try to remap remapping doesn't work. So we have to allocate a new one. This might fail. If this fails, then all the side effects that we did to P, they now need to be undone because we have, because this is bad. And that's what we do with this guy. Perfect. Well, I mean, it could be made better, but good enough. Yeah, actually, to be fair, now that I think about it, wait, when is it that we are modifying this length? Whenever there's a new length that's being specified. So in reality, all that we would need to do is iterate over new lengths and reset those. Yeah, let's do this. So we don't even need the original. So defer. Now info of fields. Add field p comma field of name equals add field new lengths. No, what am I doing? I'm actually dumb. I do need the original copy. I do need the original copy. And for each new length field, we apply original. Equals original. Yeah, there we go. We do need the original. But we only try to write back values from new lengths. And the voilen. Right. Oh man. It's not as simple as that. Because this might be void. So we need to also check if that is void. Oh, actually, no. No, you're right. We don't set anything. Okay. We should have also done correctly the undo procedure. Let's see what happens now. Root expected type found. Pointer to Rux node 269. What? 269. But That's what? Accepted type root uses node found rocks. Structure clear here. Yeah, but 269 is. Oh, come on, man. Oh, wait, is it flex? Oh, I'm blind. It's not rocks. It's flex. Many things with an X. So 269 in here. So new is p dot star. Oh, you know what? We also, well, no, we don't need to do it in the other case. Only here. New dot star is p dot star. Yeah. Okay, we're gonna crash. Index out of bounds. Index 3, length 3. Fair. This needs to do -1 in its initialization. Next problem, integer overflow. Yeah, going backwards with this is annoying. God damn it, man. This is annoying. But I guess we can do saturation. That works. Let's see. Start index 8 is larger than end index 0. Uh, yeah, you're right. 273. Is this in here? Yeah. So this is actually kind of right because old size is not like the end is the, it's like this. Yeah, that's how it is. Same here. So it's a size, it's not like an end position. So that works. But also, why was it 0? That actually fucking sucks. Why is it 0? That does make sense. I guess we should say, I guess we can, I guess mem copy will know that if this a mem copy of length 0, there's nothing to do. It should be fine. Okay, let's see. That's failure. What's happening? Start index. Huh. Huh. Data. It's larger than end index 16. Yeah, just a little bit, isn't it? Hmm. What am I messing up? How is new offset not set? Oh, because of this stupid rule. Oh my god, this rule is so dumb. Yeah, no, I can't do this. Because no, align forward is fine. The problem is that I was say originally I was thinking, well, if a thing doesn't move, then we don't need to do anything about it. Like we shouldn't write it down in deltas, but we should. And the defer was also was malfunctioning. Okay, so let's see. Source and destination arguments have non-equal lengths. Root 267. I'm guessing 6, 7. Well, yes, they don't have equal lengths, motherfucker. This is a the length is not specified for this guy. Why are you so picky now? Destination must be a mutable slice, a mutable pointer to an array, or a mutable many item pointer. It's a many item pointer, and this guy is like, what's your problem? So there you go, 0 d dot old size. Are you happy now? Oh, now it works. That's a weird problem though, because it's supposed to accept length information from either side. Yeah, I'm slouching. Okay, so I guess you need to pass it down no matter what. Fine. Now you have it. Okay, I think we got our math right at this point. So this is cool. And here we need to mem copy everything every single time necessarily. But here we can make an optimization where we can say don't mem move things onto themselves. Does it have any information in my representation as a destination element? Similar to loops, at least one of source and destination must provide the length, and if two lengths are provided, they must be equal. Oh, you know what's going on? I guess because some of this information is known at comp time. I don't know what exactly where, but maybe what was happening is that we were pointing to some known length, even though we shouldn't have. Although that seems weird to be honest, but anyway. Now this works. Okay, so in theory we did everything correctly. We'll see. So with this, we have implemented this all correctly. Do we also return the new pointer in this case? Yes, we do. Amazing. Amazing. Okay. Okay, so now we can do the rest. Basically, we have implemented this entire if. What's the next step? Okay, so this is what we need to implement, right? This is the function. Yeah, generic insert. We have implemented this. Next, we need to implement down here. So this is the algorithm one that we need to implement. Copy. Okay. Let's see. So if we're in a merge node and we haven't matched the entire string, then it means that we are going to need to take this node and split it into different nodes. Ooh. Yeah. Let's see. So one, save the next pointer. Rax node last child pointer. So save the next pointer. Okay, so save the next pointer. This is again a pointer to pointer. So we're taking a pointer to, this is basically a slice to pointers. But why do we start with that? Why do we start with that? Hmm. As well, a project coded in Zig, the build system coded in Zig. Could we expect bright shaders in Zig in the future? Yeah, this is actually already being worked on. Zig has a Spear V backend. So the idea is that you write Zig code and then Zig can output Spear V, and then you can use that with GPUs. Last I checked, only compute shaders were being worked on. but I haven't checked in a while, so it might very well be that now shaders are being supported. I am fairly certain though that there's not an entire like fully functional backend. There's some of that, but not all of it. So you know what? I don't want to copy this mindlessly. I want to see why we're doing this. What is going on before we do other stuff. Let's see. So here, because I feel that some of these might be C-isms. So we grab a pointer to the child field, and then we copy in next. We write to next. Fuck, I don't remember how CMM copy works. Size of next. We're copying from this to this, right? Hmm. But the fact is that we're grabbing a pointer. So why are we grabbing a pointer? Because because this is where we need to copy. So this is the destination. So we're trying to write in here. Wait, is this just an overcomplicated way of just saying or just doing this? So const next equals h dot ptrs dot slice at 0. Is this it? Like, is this really it? I think this is it, right? Doing main copy is one way to avoid UB when casting types. Oh god. Okay. Okay, so we save the next pointer. Then there's some debug printing. Then set the length of the additional nodes we will need. Right. Trimlen is J. Postfix len. Postfix as in suffix. Is h.bytes.len minus j minus 1. There's 5 characters in our node. 3 have matched. So we subtract them. And then I think the minus 1 is because j is the character. Actually, the j hasn't matched. The j is the first character that hasn't matched. So that's why we do j minus 1. Okay, suffix len. Split node is key. Not j. So if j is 0 and h is key and the not h is null, I'm starting to question, is null. Not is null. Why not is null? Why? What if it is? What if it was null? What does this null mean? Uh-oh. Now I'm starting to wonder what the heck is null is supposed to mean, because I'm not sure anymore. I thought it meant one thing. It might mean also other stuff. Okay, so in general, the idea is const print out this key if j equals 0 and h dot is key h size the node size create a split node. Also allocate the other node will need ASAP so that it will be simpler to handle So we create a new node for the split node. So the idea is, yeah, we're making a split node. I don't understand what this null means then in this context. H is null. I'm gonna leave a comment for this. Because I don't know what that is supposed to be in. So split node, trimmed and postfix. Yeah. We will end up with this layout. Abort now that the tree is untouched. Okay. So from here, oh fuck. I hate this thing that these editors don't support the concept of the cursor going off screen. It's so 1970s. God damn it, man. Okay. Create a new node of size 1, of extra size 1, and then oh, 1 is the key. I think it's like this. These are the lengths. I guess we need GPA. And this needs a try. And here it's value equals 1 dot split node is key. No, split node is key is value equals 1, right? I guess this is bytes equals 1. And then PTRs equals 1. I'm guessing. This one is really weird. I need to see the definition of Rack's new node because it's just confusing me right now. Children and data field. There we go. Allocate a new non-compressed node with a specified number of children. Maybe we should have like a new on racks. We have an init. No, that's on the tree. Node doesn't have anything. Data field. Yeah. Can we do that on pointers? Hopefully. Probably not. Okay, there we go. So in theory, you can call create, although this is not going to work that way, is it? Yeah. We're saying children one. Split node is key. Okay, so this is going to be our split node. And then we're making space for trimmed and postfix based on these conditions. In this case, with if trimmed len, this is like the if j greater than 0, then we do trimmed equals node create something, I think. Not even that. It doesn't. It's not using node create. It's using Rax malloc directly based on size. Well, we can look into that in a moment. But we do this here, and then down here is postfix len, which is for us is suffix len. If suffix len, what was it? Greater than 0, basically. If suffix len is greater than 0, then we create the suffix, a suffix node, const suffix. Okay, and then on we give up, which I mean makes sense. Basically, this would be like this: try third defer node dot split node dot dinit GPA, and I forget what case single. Then if split node is null, or trimline and trimmed is null, or postfix and postfix is null, then we failed. I mean, but it's an thing for us. I don't get it. What did the original code do? So we do the stuff, then we set stuff in split node, and then if j is great is 0, set something in split node. Otherwise, if j was 0, then we do some other stuff. We set stuff in trimmed. And then if there was any postfix, we fix up postfix. Okay. So I would do it this way. I would say that trimmed is an optional pointer to node. And there's a condition that makes us create it. Otherwise, we set it to null. So for example, if trimmed len, so if j equals 0 is null, else it's a node create. And then the suffix is if suffix len is 0, then it's null, otherwise create. And I think this should be the idea. But here we're doing a bunch of math. Why are we not using Rax new? We're using Rax malloc directly. Well, let's see. Node size trim len. Size of a Rax node plus trimmed len, the number of bytes, plus padding, plus a pointer to another node. This is like, okay, so, well, somebody was suggesting yesterday to add create split and create merge. I guess it's time. Then we make this layout, and I guess this can be a proper property. So the idea is bytes is children. Wait a second. I think I understand what's going on. Is anti-res not allocating a pointer to the next node if it's key? Really? Is this maybe why he's doing this? Size of void. No, but next is always added. Yeah, size of Rax node. Size of Rax node. But it gets always added. So why this approach? Yeah, let's do create with a layout property. So bytes is children and pointers is switch layout. Dot merge is the same length as children. Dot split. Actually the opposite. Okay, so now we can create with a layout. So here we create a split. Here we create a trimmed one based on trimmed length, which for us is J. I think this is a merge layout. In trimmed. Yeah, for sure. He also has only one pointer to our next node. Suffix also is the same idea, is still a merge node. So GPA, but it's suffix len. It does not have a key. It's also another merge node. Okay, and then there's management. Okay. So this should be this. And there's split node. This guy. Also, why is this split node and these guys are called suffix and trimmed and they don't have like a why don't they have node in the name? I'm gonna call this split. Split trimmed suffix. Trimmed, it's basically prefix, I guess. I'm gonna call it prefix. Okay, prefix, suffix. And then we do split. So if all allocations succeeded, and I think we can even enforce this. We can do defer catch unreachable. Actually, without catch, what am I doing? Defer unreachable. So we do split dot bytes at 0, bytes dot slice at 0 equals h dot bytes dot slice at j. Yeah. Okay. Then we have implemented this case. Okay, so we have implemented up until here. Then now we need to set data. So this is basically saying if j equals 0, replace the old node with a split node. Yeah. So the split node needs to become the new h if j equals 0, which means if there is no prefix. If there is a prefix, then we need to deal with the prefix. So I think we can do it this way. Okay, this is the case where j equals 0. This is this. If h is key, we do split dot value dot slice at 0 is h dot value dot slice at 0. And then we do parent link dot star equals split. It equals split. And then this is the else case where we need to trim the compressed node. So trim resize equals j. We don't need to do that because we've done that already, I believe. When we created prefix, we passed in j as a child count, and that does get set. It does, right? Let's create bytes is going to be children. Let's create bytes, not children. Yeah. Okay, so this is done. Then this is doing mem copy trim data h data j. Yeah, we actually do want mem copy also in our case. So at mem copy, destination is going to be prefix dot bytes dot slice. This is the destination, and the source is going to be h dot bytes dot slice 0 dot dot j. Yeah. Oh, we're deciding whether trim should be a merge or a split node based on j being greater than 1. Okay. Although we made this choice already, didn't we? Maybe we need to. Didn't we make this choice when we sized it? When we were sizing this stuff, we already made a choice of which type of thing this needs to be. Although maybe not, we didn't. Let me check the original code. If trimlen size of Rax node star. Like we always Rax padding. Okay, Rax padding is fine. But then size of Rax node. Size of Rax node star also. So we do have space for only one next pointer in this. And then this is for the value, avoid star. So no, this should be. This is a merge layout. But I guess we're saying if J is 1, then we. If it only contains 1, then we split it. We make it a split. Which we can do actually here. So we can say. If J equals 1 dot split else dot merge. So we do it there. We copy over is key is null. And then if is key, which we also did in initialization. So if prefix that is key, then value slice 0 is h value slice at 0. We can make this curlied. I think it's not a bad idea. Okay, and then let's see. Rax node star star CP. Rax node last child pointer of trimmed. Okay, so the PTR pointer, we copy inside of it split node. Okay. So prefix dot ptrs the slice at 0 equals split node. This is split in our case. Okay, we do this. We have this, and then parent link dot star equals trimmed prefix. And then parent link is this. No. Slice at 0 also here. Okay. Ooh, also, oh man. No. You know what? I would change this to prefix node, Or no, you know what? Maybe prefix. And maybe suffix. There we go. Okay, so we have implemented 3 cases, 3A and 3B. Now we have to do this. Let's do 4. So let's see. If maybe suffix else. Okay. Just use next as the postfix node. Next. Where's next? Oh, we can say suffix. Maybe suffix actually. Maybe suffix equals next. We don't know what's next, so I guess we'll have to figure that out. Okay, now we have suffix here. So create. Postfix is key equals 0, is null equals 0. So we're doing initialization, but we have done this already, right? In suffix, we don't set it is key. It's false. It's merge. Oh, postfix len greater than 1 decides if it's merged. So let's do that here. Maybe suffix. So if suffix len is greater than 1, then it's merged. If suffix len is greater than 1, then it's merge. But what did we do in the allocation though? Node size, postfix len. Okay, it's always 1, also in this case. Wait a second though. What? If suffix len is greater than 1, then it's merged, but we don't have Yeah, that does make sense. That actually does make perfect sense. Okay. Create a postfix node. So is key, is null, size, and this stuff is all taken care of. Then we will need to do this. Let's see. We need to copy over. We need a mem copy also. We as well. Mem copy into suffix dot bytes. All of them. Well, dot slice from h dot bytes dot slice from j plus one dot dot. Is it dot 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 or is it more specific? I don't think it needs to be more specific. I'm gonna leave this line here for a while more because maybe we need to reslice, but no, these two lengths should be equal. So I think we can leave the assert, okay, to do that work for us. Now we need to copy. Now we need to worry about here. So we grab the next field of postfix and we write to it next. Where's next? Oh, we have next up here. Okay, save the next pointer. That's cool. We did save the next pointer. So postfix, prefix, suffix. Pointers dot slice at 0 is next. Okay. So I have implemented this as well. And now we need to do this. Five. Set split node's first child as the postfix node. Yeah. Oh, you know what? Actually, I got this wrong because wait, these guys can also have nothing. Let me think about it for a moment. They can have the next node be null, can't they? And it might be that it is correct for this to be null. So we might need to actually make it optional pointer. Yeah, this might need to be an optional pointer. Yeah, because in low walk, Did we implement all of all walk? There's no way. So while we keep scanning, what if, for example, we merge everything? So we matched everything, and then we continue. Where's the part where we realize that one of these guys is null and we have to stop? Maybe it's just a case that doesn't apply for this search. I don't know. Okay. Something to keep in mind though. Definitely. And you know what? We might want to initialize also pointers to 0 then instead of leaving them undefined. Well, we'll figure it out. We'll figure it out once we hit undefined behavior at some point. I guess that's how it's gonna work. Set split node first child as the postfix node. Yeah. Continue insertion. This will cause the split node to get a new child. The non-common character inserted at key. And then we rex free h. Now, this is actually not necessary. Okay, let's see what is the next step. Algorithm 2. Yes, I'm gonna start copying also these comments over. Okay, algorithm 2. Whew, there's also more work here. But it's not a ton. Stop a compressed node. So what is algorithm 2? Let's see. We're seeing up here. I'll go to you know what? Let's read what's happening here. So So 1 through 4 are dealt with algorithm 1. Let's see. Yeah, this is like there's a prefix, there's a split node, and there's a some suffix. There's a there's a there's a prefix, but then there's no suffix. Well, the old stuff has a suffix, but there's no new suffix because we are basically matching everything. There is no prefix. Well, actually, wait a second. Like case 1, but is compressed is 0 into the original node. Okay, so small variation over there in the original case, and then there is no prefix where it's immediately split node and then suffixes. And then this is, I guess, the last one that remains, which is we're not splitting. Oh, sorry, we're not creating a split node. We're basically creating a So here, if you have this, and then you try to add Annie, then you basically need to take the current node that will stop that, and you need to split it into 2 merge nodes. Is this algo 2? Let's see. For case 5, that is, if we stop in the middle of compressed node with no mismatch, and no mismatch was found, then, well, I mean, this seems reasonable. I don't feel like even reading the thing. It seems makes sense to me, like the general idea. Okay, so this is it. And then there's the final common stuff. We walked the Radix tree as far as we could, but still there are left characters in our string. We need to insert the missing nodes. Okay. I'll keep pointing three nodes ASAP to fail for gracefully. Postfix len, well, suffix len for us. H dot bytes dot len minus j. Node size, because we're doing a malloc. Okay, so we're creating a node. I think we're again doing the thing where we postpone decision making over the node initialization, but I'm gonna complete everything and see what happens. So const, this is gonna be our suffix. It's gonna be node dot create. GPA. How many bytes do we have? Postfix len, suffix len, and what else? Value. Is there a value? I think there is no value, so false. And then layout. I'm gonna say dot merge, but we actually don't know. I guess we're gonna set this based on suffix len again. Let's see if data different than null. Oh, wait a second. If data different than null. If data different than null. But what is data down here? I haven't seen anything called data in a while. And I think I was checking on it previously. I think it's H is key, right? I mean, that makes sense. If it's a suffix, it's based on h.isKey. Although this data different than null thing, it's kind of weirding me out a little bit. In any case, we create it. And then we create another node called trimmed. So prefix, also order the first stuff. So this is going to be J. No, it's different. So this is based on HSKey. This is based on data. So true, I guess. Because this is what we pass in. I mean, it's get or put, so we don't have data yet. But our intent is to put in data, and we're not optimizing for data being null. And so let's see, prefix. J, and then based on HSKey. Okay. So we done everything up until here. Or the fur. Save next pointer. Again, this is going to be less complicated than it is in C. Next equals h.ptrs dot slice at 0. Create the postfix node. There we go. Here's the layout in suffix. So is it's merged if postfix len, if postfix len suffix len greater than 1, then it's merged, else split. It seems that this layout thing is always hard coded to be merge if it's greater, if the value is greater than 1, length is greater than 1, and split otherwise. So we might take this parameter out and just hard code it. We'll see. In any case, so this is for suffix. Is key equals 1, so yeah, it's unconditionally true. Is null equals 0. And yet when we were creating it, we were branching on stuff. Kinda sus. Why were we branching earlier when deciding the size, and now we don't branch anymore? Now we just know it. Kinda sussy. In any case, this part we don't do, but we do copy stuff over. So mem copy suffix dot bytes dot slice and h dot bytes dot slice. from J onwards. Set data. Set data. Right, because the idea is that postfix, this is where the input data goes. We had a set data thing also earlier, but was it? I think we were moving around H, right? Replace the old node with the split node. Split value. Yeah. Yeah, we need to be careful of tracking these things because basically this is where we need to create our GOP struct. So this is where the GOP struct should go, I guess. Or rather, in any case, the GOP struct should reference the postfix node. That's what matters. So and then we say that postfix, so suffix dot ptrs slice at 0 slice at 0 is next. Trim the compressed node. So prefix, none of these matters to us except is compressed is j greater than 1. So for prefix, we do the same. So this also is exactly the same as before. Then we have a mem copy. Okay, this is, we're copying over the data. So this is not a mem copy in our case. We're doing prefix dot value dot slice at 0 is h dot value dot slice at 0. No. The fuck am I doing? Oh my god, too many things are called data. This is this is so dumb. Oh, this is copying over the values. Never the bytes. So this is okay. Prefix dot bytes dot slice is h dot bytes dot slice from 0 up to j. Am I doing correctly with prefix before? Was it copying from 0 to j? Maybe prefix, yeah, 0 to j. I was doing it right. Okay. So we have done this, and then we set the parent link. Parent link .star equals prefix. If h is key, yeah, okay, so this starts to make more sense. Then we're moving the data into prefix. Yeah, so, oh man, this is what I was writing before. And it was Saturday wasn't under a branch. So that's why I deleted it, but yeah, it was actually right. All right, we actually did have to do it. So prefix dot value Here we're setting is key to 0, and here we're doing set data. But for prefix, yeah, we do it correctly. The fuck? Okay, prefix value. Slice 0 is h dot value slice 0. There we go. Okay, so we did all of this. Fix the trim node child pointer to point to the postfix node. Yeah. Okay, so prefix dot ptrs dot slice at 0 equals suffix. Yeah, and now we need to return. We can't exactly return 1. We need to return dot found existing equals probably false. We'll see. But then we need to return value ptr. And value ptr is, we were saying here, rucksack data postfix data. So it's the suffix. It's suffix dot value dot slice dot ptr. Okay, so here we're returning this. But in this case up here, we're not returning anything because we're not concluded. Like there's the final step that needs to happen afterwards. Okay. So we're done with this. Now we need to implement this down here. And if we do this, we have completed the insert algorithm, which is not bad. It's a lot of stuff. Oof. I also need to eat at some point. I'm going to take a quick break to eat it. So I need to double check on that. Also, there's a zine issue. What's happening? Okay. Um, mm, 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 mm. So let's see. So while I is lower than len, let's see if this node is going to have a single child and there are other characters, so that would result in a chain of single childed nodes, turn it into a compressed node. Well, how do we know this? Okay, so we have the unset pointer to Rax node child. There's an if that does stuff and sets that value, I guess. I'm guessing. Rax reallocate for data. Go to So let's add an assert here, because if we're getting here, I think we're expecting I to be lower than len. I don't think we're fine with that not happening because, well, no, I guess it works. No, never mind. It can work. So we do it here. We do this. But I'm still not convinced. Let's see. We walked the Radix tree as far as we could. Yeah. But there are still some characters left in our string. Yes. And we need to insert the missing nodes. I don't understand this plurality of it. Oh, I think I actually am starting to understand. It's this part here. Because we might be at a situation where... Okay, continue algo, I think, refers to what happens in the while loop. So we got up to here, and so we need to add this. If instead we got up to here, then there's nothing we have to do. I guess except adding like an empty node. Is that how it works? Oh, maybe we finally figure out that the heck is null is supposed to be. And then in this case, we just add an O. And then in this case we add this. And then in this case, we add, I guess, no, actually, in this case, we don't add anything because we're actually already done. So I guess this is it. This is what we're trying to do. Add this or this or nothing or almost nothing. I don't know. Okay. While I is lower than key.len. So here we were creating this Rax child. Okay. If node is going to have a single child, and there are other characters, so that would result in a chain of single shielded nodes. Childed. Turn it into a compressed node. What is this node? I guess it's H, right? So the idea is if H is a node that currently doesn't have any child, and how do we know this? We only know this based on what? On it being a split node with... It's either a split node with only one case in it, or it's a merge node. It's either a split node with one item in it, or it's a merge node. So if Oh, it can even be size 0? We might have created a size 0 thing. Could we? Yeah, we totally could have created something with size 0. Yep. And then we have also an else case. Compress the size. Rax compress node. Oh shit. We don't have Rax compress node. Rax compress node. Jesus. What does this guy do? And then if new H is null, go to Oh god. So this can fail. Well, this is actually bad. Because we applied a bunch of side effects already. Oh snap. How does the look like if you jump to there from here? Let's see. This code path handles out of memory after part of the subtree was already modified. Set the node as a key and then remove it. However, so we call Rax remove to undo those changes. Oh god. However, we do that only if the node is a terminal node. Otherwise, if the happened reallocating a node in the middle, we don't need to free anything. H is null equals 1. This is the first time that we see is null set to 1. Hmm. Well, we don't have rocks remove. So we are turning H into a compressed node in here of this size. So we're basically, okay, so we're basically resizing this node. Hopefully there's an assert. Also, there should be some asserts around. So, although no, nothing comes to mind. Okay. Merge size. Hmm. So maybe new would be there's also this ampersand child. What does that do? Why are we passing down? Why is this out parameter given to compress node? I have a quick somewhat zig question. If there is a preference nowadays in API design, imagine a Vulkan wrapper that allocates and manages images and buffers. Is it more common for Zig to have engine.init image or image.init engine? I think that neither is inherently more idiomatic than the other. I think that you will have reasons to pick one approach over the other, but I don't think it should be like, I don't think it's some like generic concept of what is idiomatic in the language that can guide you there. So for example, let me try to think of examples where maybe one approach is better than the other. Well, I guess the main distinction is because in the second case, the second case is more flexible, right? The idea is you have any type of asset potentially is a non-OP approach. The other one is more OP. I would disagree. I would say that here's how I see it. In the first case, engine.init image, the assumption is that engine needs to know what's an image. The engine uses images and manipulates them to do stuff. In the second case, it's kind of the inverse, right? It's image that is using the engine. And what I mean by that is that in the second case, the assumption, which doesn't have necessarily to be true, but the assumption is that you could create something else. So you could have, I'm gonna make up some like a very stupid example, but like you make maybe also video.init and then you pass in the engine, and then video will know how to use the engine to display itself. But if that's not the case, if it's instead the engine that manipulates these other types. And so in any case, the engine would need to, like, you wouldn't be able to independently create video that uses engine. The engine would need to have extra logic added to it in order for it to be able to handle videos. Then the second approach becomes less useful, I would say. Not necessarily wrong. So you can still do it whichever way you want. But I guess if you want, if these things use the engine, and then a user would be able potentially to make their own stuff that can use the engine, then you definitely want the second approach. If instead all these things, the engine needs to know all these things that can be done, like needs to know what's an image, needs to know what's a video, needs to know what's a cube, I don't know, then there's not a lot to gain by doing image.init and bypassing in the engine. But I would say this is the only real thing, like the only practical difference, real practical difference between these two things. They are otherwise pretty much interchangeable. So go with whatever feels right. Unless your idea is that people should be able to bring their own types that use the engine. At that point, you want to do the second one. Although, even then, you could still have, the special type, like special, let's say, built-in things that the engine knows about, and you access them by doing init foo on the engine. And then if somebody wants to bring their own, they can still do it. Doing this will not prevent them from doing the other one, but you will have like two different approaches to initialization of these types based on whether they're built in or not. One defines the init function inside of the struct, the other one has the init outside of the struct. Yes, but also not necessarily, because if you think about it, you could very well have image.init, and then you also provide init image from the engine that calls image.init. So like, if the point is if you have opinions on where the image initialization code should live, which probably should live in the struct normally, that's where it should be. Not all the time, but usually. In any case, even if you do the first approach, you can still have the second one. And if image is defined in the same file where engine is defined, then image.init doesn't even have to be public. It can be private. So I don't know. Maybe new. So this is Rax compress node, and we pass down. So this should be like h.compress maybe, which doesn't exist right now. So we pass in what? S plus I. The fuck is S? S plus I. Oh, is that the string? So is that key from I forwards? And then compress size, merge size. But oh no, it's not exactly this. Right, it's capped. It's capped. Which, I mean, now that I think about it, this can be done by @min. @min key.len minus I and std math max int u30. Yeah. And so we don't even need this. Yeah, keys from I forwards, and then the mean between these two guys. And which, oh my god, now that I think about it. just in case we need this somewhere else. Just in case we need it somewhere else. And then this is passing down a pointer to child. This is the part that weirds me out. Why? Why do we have this out parameter of child? This part I don't know. So this needs also to be tried. And if we fail, it's complicated. Catch panic to do, I guess. Bro, why are you like this? God fucking... Wait, really? But I was like here? Oh no, look at this. Merge, go to... I'm trying to go basically to here. But if I do it in the wrong place, it just sends me to hell. Oh God. Okay. So go to otherwise, and then h equals new h. So this is not really maybe new. This is new, and then it can fail. Okay, so h is new. And then we do parent link the star equals h. And then parent link becomes h.ptr ptrs.slice 0 because it's compressed. And I plus equals merge size. Okay. We're missing this management. I want to implement it though. I really want to implement, or rather, it will be a call to remove that we haven't implemented. So I don't want to make it functional right away necessarily. But I don't want to leave it this here. Like I want to have proper cleanup when cleanup is necessary. So new parent link, inserting normal node. New parent link, new age, Rax add child. More ooming. Set parent link, and then parent link is new parent link. And we pass down parent link to Rax add child, and there's this and this. The heck? What is the point of and child? I guess we use it here. Yeah, okay. I think that maybe the next thing that we implement is a pretty printer for the state of the tree so that we can take a look at how it's going. New parent link. Rax add child. So is this the parent then? But what if this remains undefined? If h bytes len is 0, And so what if h has bytes? Yeah, it's unclear to me what this guy is doing precisely and what this guy will do precisely. Okay, well, we can copy stuff over, but I'm starting to get confused. So we can do this var new parent link set to undefined, then const new is Rax add child. Again, I don't understand what this is doing. I think this is h dot add child. And we pass down key at letter I. Pointer to the child thing above, which I don't understand why. And then pointer to new parent link. If this fails, this can fail. Okay. Okay. Reallocate for data. Yeah, so we keep going down, I guess, and then we do the reallocate for data here. Oh shit. Which is another place where this can go wrong. Oof. Painful. And then is key increase the number of elements. If not, h is key. Okay. Rax set data, mem copy, parent link. Okay. I wish I'm not gonna need reallocate. No, but I do need reallocate for data as a feature. But I will hope that I don't need to do it here and we can actually do just a little bit extra math up here and make it happen in line. But well, okay, let's do it. Reallocate for data. And then we say this is something that I can fail. So catch, panic, boom, to do, sorry. And then h equals new. If h dot is key, then r dot elements plus equals 1. Then we should set data on it, but we don't. And we do parent link dot star equals h. Then we return on the existing equals h dot is key value ptr equals h dot value dot slice at 0. Okay, so this is it. Okay, so having implemented it, this doesn't exist. This doesn't exist. This doesn't exist. Okay, I have 3 things that don't exist. Man, that is a lot of work. Oof. Okay. I need food. I definitely need a food break to get more energy. Reallocate for data, add child, and compress. Let's take a look at the code. What these things are supposed to do. Reallocate for data. It's this guy. Add child is this guy. Compress node is this guy. Okay, let's take a look at these guys. Start from the last one. Compress node. Show me. So compress node, turn node n, there must be a node without any children, into a compressed node representing a set of nodes having exactly one child each. Yeah. The node can be a key or not. This property and the associated value, if any, will be preserved. The function also returns a child node. So there we go. This is this thing. Since, okay, the function also returns a child node. Since the last node of the compressed chain cannot be part of the chain, it has 0 children, well, we can only compress inner nodes with exactly one child each. Okay. So this new potential child node, I want to fucking see it now. Does it have null equal 1? No. Oh. Oh? No, okay. For now, is null is just it just avoids storing the entire void pointer. This is the only thing that it does. Okay. It's really an optimization that we don't care about at all. Okay, so this is compressed node. We're gonna need to implement that. Add child. Let's see. Add a new child to the node n. Child pointer parent link. Let's see. Representing. So add a new child to the node n, representing the character C, and return its new pointer. Oh, I get it. I get it. Right. So add child is not like add a child node in the access with respect to our concept of what's a node and what's a child of a node. This is about add a new, extend a current node to like add a new character. Yeah. Basically, the current node needs a new character. This is it. And this is only okay. So this is like it's like add a branch. Okay, so this is add a branching case in a split node. Add case to split node, basically. Oh man, there's stuff that has to happen, huh? Although I think in our case, some of these might be easier because we do, I think, better with regards to our abstractions. Because yeah, you see, he's doing a bunch of man moves, and we do that already with our with our abstraction. So we're probably going to be fine. Although this is a good check. It's going to be good to go through this and see every case, how it's handled, to double check that this doesn't do significantly better than what we do. Because if this for some reason can do smarter choices than what the abstraction can do, then it means that the abstraction is not doing all too well, and it's not all that, it's not necessarily worth the extra complexity, I guess. That's my point. Yeah. Okay, so this is also going to be a lot of fun. And then we have reallocate for data. Although this is kind of silly. It's basically just add space for data. We don't need a dedicated function for this, I think. Yeah. Hmm. Oh, I get it now, the data null check. The data null check is just because when you're making space for new data, you're doing the is null one thing. No allocation needed, setting is null equal one. Okay, so this the expectation is that this function doesn't even do that. Well, I guess it makes sense. Okay. Yeah. Oh man. Okay, so now I understand the data equals null checks. Okay, we understand null now. For real. Yeah, these are the children. Of course, they are the children. And I renamed it to bytes, but then it kind of lost its meaning. It kind of lost its meaning. Okay. Okay. I think I'm gonna take a break, and I'm gonna come back. I'm not gonna end the stream. I'm just gonna keep it rolling for, I don't know, like 20 minutes, half an hour. I'm gonna put a countdown, and then I'm gonna eat something. And when I come back, we implement what's missing. Yeah, we're actually making good progress, and so far everything seems understandable and makes sense. And I don't have the feeling that I'm, not understanding the intent behind the code. So I don't want to be too optimistic, but there's good chances that we're not like that the troubleshooting part of all this new code is not going to be too horrible. Hopefully, yeah. That said, we also need Rax remove if we want to implement handling, and yeah, that's gonna be fun. That is going to be fun. Okay, so let me do the thing. For KFK, let's do half an hour. Lunch break. See you in a bit. I'm back. Anybody still alive? Do. You know what? I want to take maybe a short break before I resume programming. Let's just see what's on Hacker News. Also, so of the people watching, did anybody see the Stack Overflow survey? The results this year? Has anybody seen how Zig is faring? It actually came out just a few days ago. And 896. Oh my god. What's on line 896? What? Oh god. Do I have 896 anywhere? I don't even have that, I think. Are we looking at the C Osser bug? Are we? I don't know. Where? In racks? 896. Well, what is assert, I guess? Oh shit. Oh shit. Maybe we are looking at a bug, don't we? I guess maybe that assert.h is defined something for as something better than just a macro. Maybe it's not. Maybe this is a bug. This is problematic, isn't it? Huh. Oof. Good point though. Man, Critical, you're on point with assets now, huh? Okay, let's take a look at any Zig discussion on Hacker News. You forgot to update your HN craze list. Zig is chic. Rust is out. Programmers aren't so humble anymore. Maybe because nobody codes in Perl. Programmers are not humble. When are programmers humble? They're never humble. It's a wired article. What? Maybe because nobody codes in Perl. Perl is a messy, maddening programming language, the duct tape of the internet. Is it? Isn't YAML now the duct tape of the internet? But at least you can tell it was made by humans. Why are people posting in 2025 about Perl? Programmers joking that it's a write-only language. Sounds about right. You write it, but seldom read it, at least successfully. Yep. Man, tell me your language is not good in one sentence without telling me it's not good. It's a write-only language. You stole my story. I don't know. Sorry. These Perl nostalgics. I don't get them. Zig profile on Apple Silicon, AI stuff, Carbon language. This is a cool project, but it doesn't address my original issue with Zig, which is that the language semantics is not even specified. Yeah, well, dude, give it time. That is, we cannot define what this memory safe program in Zig is, as we cannot even define what the Zig program is unless you define the semantics of the Zig program in terms of implementation / transition to ER, which is fragile / bad. Okay. Second, I would be surprised. Okay, you know what? Let's go. What is the context of this enlightened discussion? No need for me safety in the language. Simply check compile time. Oh, okay, so this is the Yazaki Yonemoto talking about his stuff. Hmm. So not a lot of new interesting discussion. Let's take a look at the Stack Overflow survey. Annual survey. Wow, look at this thing. Man, they really know what's up, huh? If they know how to connect these graph nodes here in the header, man, this survey must be really on point. Let's go take a look. View survey results. USA and Germany and India are the top countries responding to this year's survey. Yo, Italy is here. Italy, as usual, last of the first. Love my country. Now, how some people desperately want to dunk on Zig for being broken despite the language not even being finished or declared stable. Yeah, I mean, it's a fair criticism that a language needs a spec to. Well, I mean, let's say at a certain level of adoption, you kind of need to have a spec because people will want to have their own compiler. Plain and simple. Let's put it that way. But yeah, it's like 0.14, dude. Like, relax. We've just remade the entire IO system from scratch. Spec will have to wait a little bit more. Yeah, last of the first, as usual. And I'm still surprised, though. But as usual, France, twice as good in that. You know what? Although I wouldn't say twice as good. Never mind. Let me take this back. Answering the Stack Overflow survey, it doesn't mean that you're doing well in terms of technology. It actually comes with its own set of downsides. That said, I do think that in this context, we can, at least at this level, we can argue that this is a proxy for the general level of like software participation in the global software scene, and I think it's true that these countries are participating in the international software scene way more than Italy is. And I don't know, it would be nice if people around here participated more so they would be less dumb and I could have smarter conversations with people that live next to me. That's basically actually the entirety of my point. The compiler was entirely rewritten like 3 versions ago too. Yeah. As a Frenchman of Italian descent, I agree with French. France is twice as good as Italy. Listen here, Blurrycat. I'll say one thing, though. I will admit that I'm not an expert in French cuisine. I have been to France not a lot, and I was young, so and I didn't get to pick my the restaurant by myself. So when I went there, so I don't have, I don't know a lot about French cuisine. Also, obviously, you need to visit different regions. I'm sure that things are not going to be the same everywhere, obviously. But I grew up in Piemonte, where Turin is, which is the region of Italy right next to France. So north west. And cuisine in Piemonte is heavily influenced by French cuisine. We have our own version of ratatouille, for example, and a bunch of other things. And I will say one thing. I like that type of cuisine, partially also because I grew up with it. But I do think that there are quite a few other influences that are superior, at least in some way. So not strictly superior, but at least in some way superior. And long story short, I need to go to France and see what's up and see what the original thing for myself. And then I'll be able to make statements. But for now, I'm a little bit suspicious. Where do you draw the line between Western, Central, and Eastern Europe? I have no idea. I guess Slavic countries are Eastern Europe, for example. I don't know. I would put the line more or less where, I don't know, Poland, Estonia, Lithuania, Hungary are. And then everything else is Central/Western. I would say the Western, I would say it's more Eastern versus Western, or if you want, Central versus Eastern. I don't, when you're trying to make this distinction, is there any point in separating Spain from France, Italy, and Germany? No. Usually when you get to that point, the distinction is like Mediterranean countries versus, well, non-Mediterranean countries, like countries like that face the sea versus countries that don't. And even then, it's not exactly clear cut, because I guess you could maybe group together Italy, Spain, and Greece, but then France also is exposed to the Mediterranean Sea, but usually doesn't get grouped with Spain and Italy. Yeah, Western plus Southern. Yeah. So I don't know. Usually this type of distinction, what is it? This type of distinction tends to be more Western, Eastern Europe versus like the rest. Blurry said Western Europe, so usually it doesn't include Germany from what I see. No, yeah, no. There used to be a point in time where people split Germany into Eastern and Western, at least Berlin, but no, it's Western Europe. I mean, it is central. Like if you really want to make a distinction between Eastern Europe, Central Europe, and Western Europe, you would put Germany in the center. Then maybe you would put France in Western. Maybe, I guess it depends on how you want to look at it. But anyway, so we need, you know what? We need more Europe. Like we need more Europe technology. Stop having only lawyers that make laws in Europe and regulations. Let's have software engineers that make also good software. Think about it. We're letting the fucking United States do all the software for us. And these are people that like mac and cheese, that have complicated opinions about fucking fast food and snack bars. That is the level of sophistication in their appreciation for what is good and beautiful. We cannot do that. And by the way, and as much as I'm making fun of the United States, the thing is, we're worse. We're not doing it. So we should be able to do better, but we don't. So I don't know what the answer is at this point. Go answer the Stack Overflow survey next year. I don't know if that's gonna help, but isn't Andrew an American citizen? Yes, he is. He is a US citizen. And making software for us, he is. I mean, you know how it works, though, right? I can promise you that in Italy, there's people that don't know how to cook, and they, I don't know, don't even have. I know people that don't eat fish, they don't eat prosciutto. This thing here, just for clarity. I know people that don't eat this stuff, and on paper they're Italians. So you know. Individuals come in all shapes and forms, and they don't always align with that with you know the rest of the population. That said, you can make statements about you know how things are in general. The United States likes mac and cheese, unfortunately, and they work hard to make it a thing, even though it shouldn't be a thing, but it is. So, and they get mac and cheese software, and we use mac and cheese software. That said. As I was saying earlier, then what is the alternative? We use software that we make ourselves. Well, we're not making software ourselves. Look at this. There's 10 times the participation. I guess these countries are smaller, so it's fair, but still. Oh, actually, you know what? To be honest, if you normalize this for size, probably it's not that bad. Italy is smaller than France, so I guess it makes sense that in the end, you know what? Let's start to make ratios. Let's see how this works. Italian population. So 58.99 million. Okay, let's say 59 million. Come on. So Italy, 2.4%. So what is 2.4%? You know what? Let's do it. Let's do it cool. So what is 2.4% of 59 millions? Let's go do that. Oops. The dash. Oh, come on, Google. I can't undo. Okay. 1.416. I think I'm doing something wrong because we don't get this, do we? This is not millions. This is wait a second. Because the original number 2.4% is over the respondents, yes. So I guess we can use these numbers to look at ratios, right? We can compare, but obviously this is not going to be the right number. So this is what is it? What do we call it? Like normalized percentage. So normalized percentage of respondents, right? So I think that's how it is. Let's do France next. Time to see if France is actually better than Italy or not. So this is 4%. France population 64.52 millions. Okay, 4% of 60. I'm gonna round up of 69. 276. So what was it? 69 millions, 4%. 2 point, what was it? 2.6? 2.76. Okay, let's just leave it as a percentage. So yeah, god damn it. France is doing better, huh? Almost twice as better. So because at the end of the day, the two populations are not that different. But France, in terms of territory, is bigger. So I guess it's just less dense than Italy. That is interesting. Let's do Germany. And then let's do United States. So population of Germany. I am expecting Germany to be actually much bigger. 83 million. Okay. 83 millions. And I mean, I should do 84 since I'm rounding everything up. 8.6%. Of 84. 7.22. What was this percentage? So this is 84 and 8.6. Man, Germany is not so bad, huh? Germany is more than twice as better than both in Italy and France combined. Okay, United States, 20%. 340 millions. Okay. 300, so what is it? 20% of 340. It's 68. Well, let's do USA. I don't remember how was it, 340 millions, something like that. And it was 20%. And then it was 68. What is your unit of competition population percent of response percentage? Yeah. I mean, the point is that, okay, maybe you can argue that the math is wrong. If so, do let me know and maybe suggest a different approach. But my point is, I want to take these percentages, the ones that are in the Stack Overflow survey, and I want to normalize them by population size. Because obviously, let me give you an extreme example, right? There's a super tiny country with 10 people in them, and all of 10 have filled out the Stack Overflow survey, and they end up being a tiny percentage, but compared to the population size, it's actually gigantic. And now that I think about it, this formula is probably kind of crap, right? Because if this was, we would take 10%. Yeah, this is dumb, isn't it? Oh man, we have that. I'm doing, not only I'm doing wrong math, I'm also doing useless math. Oh, you're right, because you can click around and see what they give you. So per country, top 10 countries, where do you see? Is it in download? To the list of all countries. Okay, all countries. Oh, there we go. Frequency. Okay, so what we want... so what we want is the frequency. So we want to take the... Yeah, so my numbers were totally bogus. Because the United States of America, it's 7,000. Germany is 3,000. So the United States is like 10 times as big, and it had twice than Germany. Yeah. So long story short, we are participating then. It's not that bad. Italy has 883 submissions. Yeah. France 1,400. Okay. And Germany being what? Germany being 84 millions against 59 millions. So Germany is not that much bigger than Italy and France in terms of population. It is bigger, but not dramatically so. But there is a lot more participation than both of us, both of France and Italy. I guess this is maybe the language barrier. I don't know. So why is Germany not making more software, more better software? God damn it. Okay, let's go take a look at Zig. Enough of this. Technology. There we go. Programming. Are kids graduating from college even going to Stack Overflow now? Well, German ones are, apparently. I agree. Stack Overflow kind of sucks. I don't like it. I never liked it. I do have a Stack Overflow, although I do have a Stack Overflow t-shirt. But that's because I got one at a conference, and I don't know, it lasted up until now, so I keep using it, but I don't really care for the brand. I never used Stack Overflow. Yeah, every time in the past, that I had an issue and I landed on Stack Overflow. For me, that meant one of two things: either I wasn't like knowledgeable enough to pull off what I was trying to do, or the thing that I was trying to use was too ill-designed to basically make it reasonable for people to understand how to use it correctly. To me, like going to Stack Overflow instantly meant that you kind of failed the mission, because you should have gone to, like, the docs should have allowed you to figure it out, whatever it is that you're doing, roughly speaking. So I don't know, never had any respect for Stack Overflow personally. And I agree. Stack Overflow pretty much, it kind of died. At least the Stack Overflow model died when AI came out, because the point is that Stack Overflow gives you a bunch of wrong answers. So you can get the wrong answers faster with AI. So why go through the extra steps of going through Stack Overflow? And not only that, but AI is also trained on Stack Overflow. So all the wrong answers that you have on Stack Overflow, you can get from AI. So it's not like you're missing out on anything. So yeah. Okay, let's take a look. So JavaScript, number one. Oh, I think at some point Python had caught up with JavaScript, which I find interesting. And there's also TypeScript. And JavaScript and TypeScript, they have some overlap, but they're also kind of in mutual exclusion. So at the end of the day, if you want to compare like web versus Python, JavaScript is much bigger than Python, because some of JavaScript is being eaten by TypeScript. I mean, again, not entirely. There's probably a lot of overlap, but still, there are some people that do TypeScript and they don't really do JavaScript. And for them, like, if you count all of this, then Python, I mean, it's close, but it's not really a head-to-head. Most people doing TypeScript are also maintaining JavaScript. Yeah, for sure. But you don't have to, right? Strictly speaking, there is somebody out there who is enjoying a pure TypeScript experience. In any case, HTML, CSS, very high, cool. SQL, very high, cool. Bash shell, very high, cool. Java, very high, not cool. C#, very high, not cool. C++, very high, not cool at all. PowerShell. I guess PowerShell is just the sad cousin of Bash's shell. Then C. C is just slightly below C++. I wonder if the people that vote C++ also vote C. You know what's funny? Stack Overflow has this info. Stack Overflow knows how many of these C++ votes come from people that also said C or not. They know this. And they don't show this info here. Because it would be interesting, right? To know what is the percentage, like how much of these is overlap or not. Anyway. PHP, I guess some of that is shown later on when they show like migrations, I guess. But still, C, PHP, Go, Rust. Rust is catching up with Go. Holy shit. Holy shit. So I think this is interesting, right? Because if you take a look at this, if you take a look at star history and you do Golang Go and you do Rust lang Rust, holy cow, it is catching up. Never mind. I was about to say I somehow was convinced that you would see a much bigger gap between these two guys, but no, you don't. They used to be much further apart, right? You had a lot more distance. I guess time has passed. Although this is 2018, maybe I'm just misremembering. Online timeline. Yeah. Boy, Rust is coming for Go. And holy shit, we are also coming. Still far behind. But we're also coming. It fell off a cliff comparatively to previous years. Where do they write? Oh, there we go. Over 49,000 responses. While, let's see, 2023? How many? 90,000 developers. Over 19,000 developers. So it's like half as much. Let's see, 2024. 65,000. 2022. 70,000. 80,000. I don't remember. 65,000. 90,000. I mean, it oscillates. I mean, you can see, I mean, you can suspect that there is a downward trend. Fine. But they also had ups and downs in the past. 64,000. I don't know. Let's go back more. This time we analyzed a survey sample of 7,500. Okay, so these were small. So it got big. And yeah, now it's in a downward trend. But you can't fully count them out yet. Probably you should. I mean, like, I would not bet that Stack Overflow is going to gain in popularity going forward. But yeah. The Reddit technique. In any case, so Go and Rust head to head, coming for PHP, and C and PowerShell. Okay, so assembly, Ruby, Dart, poor Ruby, Dart, Swift, R, fine, Groovy, fucking Groovy. Does anybody here do Groovy? Does any of you write Groovy? Actually, answer two questions. Do you write Groovy? Would you write Groovy if you weren't forced to? I guess these are the two answers that I want. I find Groovy one of the most disgusting things ever created. People using Jenkins have to. Jesus. I see. Build.gradle kind of used to force people to use it on Android. Gradle uses Groovy? I didn't know that. Man. I feel like I had such a happy programmer childhood. VisualBasic.net, VBA, MATLAB, Perl, blah, blah, blah. There we go. Zig is down here at 2.1%, and we're coming for MicroPython and Lisp. But here's something interesting. I hate Gradle with a vengeance. Mm-hmm. Here's something interesting. If we look at the 2024 Stack Overflow survey, and we look at Zig, Zig was below Julia in Clojure, and it was at 1.1%. And we went from 1.1% to 2.1, which seems good. At the same time, MicroPython also went up a lot with us, and Lisp also went up with us. Julia kind of got fucked, but Julia is not in the list anymore. Like, they took Julia out of the list completely, which is an interesting choice. And if I remember correctly, if you scroll here and you look at write ints, now Julia had to be added manually. It shows up twice, or as have used and want to use. Okay. But it used to be at like 1%, and now it's 0. Nothing percent. I guess because they took it out and people don't write the number in. Loading on the list. Yeah. But only in want to use, not in have used. So, what is my point? I guess my point is that the fact that this percentage is changed, I don't know what that means, because it's not really entirely just growth from last year. Maybe. Databases, Postgres, first place. Redis. Redis has fallen below Microsoft SQL Server. Man. Redis used to be the first. Redis used to be at the very top. And now people don't care anymore. Somebody wants to use CouchDB. Do you? Are you sure? Couchbase. These are people that work at Couchbase. They're the only ones that say they want to use CouchDB. Cloud development, NPM, Docker. Let's go. Heap. Oh, my favorite ones. Kubernetes, Microsoft Azure. This section is a complete soup of things in a way that, I don't know, doesn't make a lot of sense. Cargo. Bun. Oh, I think this part cracks me up. Yeah, so yeah, it's a weird soup. Well, Cargo is in there, I guess, because NPM and Peep are in there, and Yarn, and NuGet, and APT, and then also maybe if you squint, also Make. It's kind of a weird soup. No. These charts were insane also way before AI. This is like a staple of Stack Overflow, having this soup section. But then they do this thing where they have Bun in here, and then they keep Dino in this other section, and Bun does not show up in here. Why is Bun here, and why is Dino here? Why don't they make Bun against Dino in the same fucking chart so you can compare them? Instead, they split them apart. Why? I don't know. So Dino is at 4%, fighting it out with Symfony. Under Ruby on Rails. And Blazor. Jesus Christ, fucking Blazor. Dev ideas, Visual Studio Code, number 1. Let's go. Followed by Visual Studio. God save us. Followed by Notepad++ for some reason. IntelliJ IDEA, Vim, and then Cursor. Holy cow, look at Cursor. And then PyCharm, Android Studio, Jupyter Notebook, NeoVim, Nano, Sublime Text, WebStorm. Zed is at 7%. Is there Helix in here? There's no Helix. Did people do Helix write-ins? I think I did. I have used 0.1% Helix. Emacs is a write-in? Excuse me? Also, let's see what learning to code people do. A lot more Visual Studio Code. way too much Visual Studio. Holy cow. Emacs and Helix were in the list the last time. They took them out. Interesting. So why are new people doing 31% of them are like using Visual Studio? Why? Why would you do this to people in 2026? Well, 2025. Why not? Because it's ass. It takes forever to install Visual Studio, not Visual Studio Code. Visual Studio, the non-code one. It takes forever to install, like forever. It's slow at booting up. It's slow at shutting down. It's kind of ass at doing everything. Yeah, except being a debugger. But you know what? There's alternatives. There's the Rad debugger. This one. Use this one, I guess. Although, well, it's Windows only, but I guess also the Visual Studio Debugger stuff is Windows only. So, in any case, use the Rad debugger. On Windows, you need it to build. Fair point. Not with Zig, but fair point. Nano. Lovable.dev. The heck is lovable.dev? Build something lovable with AI. How? How? How do you build something lovable with AI? How? Is IntelliJ good? I'm sorry, I don't know. IntelliJ is for Java, right? So the answer is that it kind of can't because you're writing Java. Stack Overflow tags, don't care. Community platforms, don't care. Large language models, super don't care. What is Z? Is a new editor. Oh, I can show you what is Z. Check this out. I read that Z added support for Helix keybinds, so I wanted to try it out, and so I installed a new version, and I have it here. Check what happens when I open it. So basically, it starts eating my computer alive, and then it like never stops. My mouse is lagging right now. And after a few moments, I can't interact with the program anymore. It's stuck in here. I have no fucking clue what it is doing. It's just completely eating my computer alive. I don't know what to tell you, Blurry Cat. It's like this. And then I kept it open for a while, and it kind of like never recovers from this. Restart, reinstall. Here's the thing. I guess I don't know. I guess I could try to delete it and then by install the new version on top of the old one. Maybe I should do that. Okay, force quit. So restarting the computer doesn't do anything. I mean, I've already restarted my computer, and it keeps doing this. I guess we can try to drag the whole application in the trash and then create a new one. So let's try doing that. Because I did do the install on top of the old install. So move to trash, empty trash. Yeah. Then I think I have it in downloads. You know what? Fuck it. Let's install a new. Let's download a new one. Configure the wait, z.dev, right? Dev. Download now. Download a new copy. rf dot config home slash dot config slash z. Yeah, removed it. Maybe that will help. I mean, if that doesn't help, then I don't know what will. Agree. Drag. Do you still remember when you first learned about Git and GitHub? Roughly, yes. I think it just fucking hates me. Close editor, close window. Can I like close the folder? Well, I can't do anything at this point. I don't think it really saved. Yeah, no, you're right. It might have loaded my previous state. It's either that or here's what else might be happening. You know what? Let's delete also .cache. Please, computer. Can I see the start bar? Oh no. I can't see. I can't be shown the start bar anymore. Sorry, the dock, whatever the thing is called. Kill all Z. Can I see the bar now? I can't see the bar. Can I tab? I can tab. But why is my bar gone? Who do I blame? I'm trying to get it to show up. Is your settings bloated? What do you mean? What settings? System settings. Desktop and dock. Don't hide it. Yes, hide it. Okay. Now it's working again. Dude, I just want to edit a text file. I just want to edit a text file, please. Okay, let's try to remove more stuff. So not just config cache Z. There's also cache Z. Let's try now. File, close editor. Don't save. Oh no! Bro! Local shared Z. Okay. Force quit. Remove cache. Remove config. Remove. I don't have local shared Z. File. Close editor. Please. Remove from project. Please. Please stop. Stop. It's a little bit of a Rust moment, isn't it? So this is a little bit of a Rust moment, isn't it? Like, I'm trying to imagine what it might be doing. Maybe it's compiling an endless amount of three-seater grammars. At least, you know what? At least it's now, you can interact with it. It's not dying. Previously with open stuff, it was completely dying. It's still eating my system alive. Like, what the fuck is going on? And I can feel my mouse lagging, by the way, and like the window is also like not smooth when moving. So it is eating my computer alive, no joke. But like, what is going on? At least it's arm not spinning, yeah. Sorry, at least I'm not spinning on x86 64, yeah. But I don't think this is just spinning. I think that this guy is doing things. Introducing the debugger. Bro, I just would like for my editor to boot and at some point stop using 98% of my system resources, like on average. Like, what the heck? Let me open, actually, let me open a bigger htop. What even is going on? Like, it's just the Z executable doing this. It's not even subprocessing to anything else. Like, Jesus Christ. Instruments. Oh, I have to install. Right. Oh, no. Now it's going to be Apple versus Z. Yo, it stopped. It succeeded. It did it. What? We don't know. We'll never know. Just quickly compiling some AI model, maybe. Notification panel. Agent panel. Welcome to ZAI. Can you uninstall this? Debugger. Shell. Welcome to ZAI. No, thank you. So we succeeded. Settings, open key binding, open settings. Theme one dark. UI font size. Sorry, I want to keep this here so I can see if doing stuff causes this guy to go insane. Okay, I'm gonna open Bork. What happens? Config options, zig path, expected execute got zig. Yeah, that's fine. Load scroll 1 year ago. Okay. Honestly, like this extra code intelligence, I like it. This is cool. We can increase font size. This is cool because I need that for the stream. Editor controls, inline hints, inline values. What's inline hints? Oh, type hints. I guess, but no. We already do a pretty good job with inline hints in Zig itself. Yeah, I know. That's why I wanted to install it and open it. But they have something. I just don't know how to turn it on. I mean, okay, it's going to be in the settings. I was just hoping that this thing had settings that weren't just a file to edit. Does it at least have suggestions? Oh, it does have suggestions. Okay. So we can do Helix. Helix mode. True. Okay. Yo. Yo. It works. It doesn't work. Okay, some stuff works. uh so yeah, no. Now it's doing it. It's selecting lines. But I selected some stuff and then I press S. But S deletes. I don't know why it deletes, but it does that. Also, what is this symbol? Toggle code actions. Oh, these are code actions. Okay. And I guess ZLS is unfortunately suggesting code actions every fucking where. Yeah, we don't have enough of Helix, honestly, unfortunately. But we do have some stuff. Space mode, like go to definition. Go to definition deletes. No, dude. Space K goes up. We still need stuff. I have to say, I see. Oops. No. Oh well, you can go close. So there are some things that make me think of that this is a good editor, but at the same time, can we do next tab prev? Settings, keybinds, next tab, next panel tab. Yeah. Modify, edit keystroke, save, prev tab. Save. No, it's not really working, dude. Come on. Well, Zed, goodbye. It's been a pleasure. You know what's an editor? What's another editor that has Helix keybind support? Flow. Let me git pull. Look, new improvements just dropped. Let's see if we can zig build. It is zig 014. Right. Neurosite needs to upgrade. Yes, Flow has Helix keybinds, but they're not all. They also need more work, but he made progress. So he has Flow mode, Emacs mode, Vim mode, Helix mode, and some people have been contributing to Helix mode. Not me, because I'm dumb, but others have. And I'm in Helix mode. Find file. We're in Flow. I don't know. Then I'm gonna open main.zig. And so I can, X, select multiple lines. I can yank, I can paste. I can undo. Man, look at these. Look at these diagnostics coming in hot. What do you want to bet that they don't come in this fast in Zed? Like they come up the next frame after our paste. There's a frame for after we paste, and then frame right after they come in. Let's see how this goes with Z. I suspect it's not going to be the same thing. So we're going to open flow. So what are we copying? List languages. Up until version info. Let's see how it fares. Yank, paste. Yank, paste. Yank, paste. It's not yanking everything. It's yanking only one thing. The heck? I mean, we see the red squiggles very quickly, though. Why is yanking so broken, man? Well, okay, so I guess we can do this. Command C, Command V. Command Z, Command V. It's fast. Okay, it is fast. It's not slow. Though it's not as fast as Flow, I think. It's not as responsive as Flow. Yeah, but for example, S, we don't have S for select rejects, unfortunately. Yeah. Some stuff is implemented, some it's not. How do you exit? Oh, I guess like this. Okay. Well, we messed around enough. I think it's time to go back to doing some actual work, huh? So what were we doing? We were here. We were... So we have zigflex open. Root. Okay. Let us see. What were we doing? Right. We just we use add compress, add child, although add child for us is something different. Add child is like add byte, basically. Add byte. And so let's call this byte, I guess. And then new parent link. But no, wait, child is something else because at some point we do assign child. Where is it that we do this? Like if I call this guy byte. Yeah, no, byte is not that. Byte is child, actually. Okay. I guess we can start implementing add byte and then we look at compress. I think add byte should be the easier one. So it's a node thing. It's not public. And then it actually returns something. It returns a new pointer, potentially. Actually, no, it always returns a new pointer. Child parent link. Okay. And then two pointers. Child is a pointer to node. And parent link, new parent link, is a pointer to node. Starts getting trippy, huh? So now let's look at the implementation of this function. Oh, perfect. Oh no, okay. Add child. Adds a child to node and representing character C, and returns a new pointer, as well as the child pointer by reference. Additionally, parent link is populated with Rax node pointer to pointer of where the new child was stored, which is useful for the caller to replace the child pointer if it gets reallocated. Yeah. Okay. Bro, please. Assert that we are in assert that n.layout is dot split. Then what? No, then we have to do some work. Let's see. Although, you know what? We assert that it is not compressed. It's a split node. And we assert, we also should assert that it doesn't have anything in it. But is this really the case? Yeah, because we are resizing, right? So we should also assert something else. We should also assert. No, never mind. I was about to say you should assert that it's empty, but no, we should not assert that it's empty because we might want to add a byte to more than just add byte. This is add split byte basically. This is the actual name. Okay, it has to be a split. So we know how this works. It's literally just const new equals flex dot resize node GPA and well, we need to accept GPA. No definition found. What is the problem with that? We didn't leave anything broken down there. So why can't we find resize? Invalid built-in function may move. Oh, I know why. I know what's going on. Zig up master. I was back to Zig014 and a few things didn't add up. There we go. There we go. So void len is going to be n.bytes.len. New lengths we need to define. Okay, what do we want in this new length? We want dot bytes to be n.bytes.len plus 1. And we want PTRs to be n.bytes.len plus 1. So with this, so this can fail. If it succeeds, that unsigned binaries from the internet without any warning or consent. Well, VS Code also does the same. Or rather, I don't know if VS Code, vanilla VS Code does that. I'm guessing maybe no. But the moment that you have an extension installed in VS Code, that can install whatever the heck it wants, like download binaries from the internet without anybody checking what's going on. Okay, so now we have the resize. There's no pop-up in Z. I think that if an application is downloading stuff, you don't necessarily see a pop-up in VS Code either, though. I think that usually what happens is that applications, extensions, try to communicate what they're doing, but I think they are pretty much unconstrained. So this is our new node. Now we need to write down the byte, the child. Okay, now I know what we are returning. We are, so set the byte. This is going to be so easy for us, by the way. Set the byte. Setting the byte is new.bytes dot slice at n.bytes.len -1. And that is byte. And then we do PTRs. Yeah, the fact that we put in here. Okay, so we need to understand what to put in here. So this is what we need to understand what to put there. And then we need to do this. New parent link dot star equals new dot ptrs slice. Oh, I know what's happening. So here's what's happening. I suspect that we didn't read that implementation, but here's what I suspect it's happening. I suspect that we're doing a sorted insert. We are not inserting characters at random. I think that we are inserting these characters in a sorted fashion. So that means that there's some of the code that the other version of the C version of this, it's doing a lot more stuff than what we're doing right now. And I think it has to do with sorting these bytes. I think I might be wrong. Let's see. Parent link pointers slice. This is the new parent link. And we need to understand what child is. I'm guessing we are allocating a second node for this. Unless the assumption is that we read from it and this is given to us. In that case, it would be this. I guess we have to see what the C code does. So asserts that it's not compressed. Calculates the current length, increases it by 1. We'll update it only on success at the end. Okay. There we go. So it does create a child node. Allocate the new child node will link to n. Okay, so we're giving it a child node with a 0, 0. There we go. Is there no other init that we have? We have this creator accepts all the options. Oh, this guy does it this way. Okay. All right, it's above. So, okay, we create a child, empty split mode, and then we do new. So this is it. And then we do child equals, so this is not optional. Child.star equals child. This can fail. Let's do this first then. First we create the child. Pair defer child.the_init. New child. There we go. So new child the init, then we try to resize this. Pair defer unreachable. And then this. I mean, there's nothing else that we need to do. So this seems pretty decent as is. Let's see what this code is doing because it's going kind of bonkers. Tries to create a child. Tries to realloc the node. Let's see. After the allocation, we have up to 8/16, depending on the system pointer size, bytes at the end. That is the additional char in the data section. Plus 1 pointer to the new child. Thus, the padding needed in order to store addresses into aligned locations. So we start with the following node having ABE edges. We assume 4 bytes pointer for simplicity. Each space below corresponds to 1 byte. Have the header. We have, why is there a star? Oh, because header is 4 bytes. Then we have some letters. Then we have A pointer, B pointer, D pointer, E pointer, auxiliary pointer, well, the data pointer, okay. After the reallocation, we need 1 byte for the new edge character plus 4 bytes for the pointer, yeah. Okay, so now it presents, let's see, move the data pointer at the end so we can maze with the data. So we start from the end, yes. Compute the shift. That is how many bytes we need to move the pointer section forward because of addition of a new byte. Note that if we had no padding, that would be always 1. Okay. We're not doing this because I've implemented this in my abstraction. Like the mem move, that's happening in my implementation of flex array. So blah blah blah. I think we're good. I think we actually did pretty much everything. Way fewer lines of code. Yep. Yep. We can even do this const and last equals n bytes.len last plus 1 last plus 1 last. There we go. Even more succinct. This is really nice. Fewer lines than what? Than the original C implementation. Although, because we're doing this work in another place. So it's not magic. Okay, so we have add split byte. So this is done. Then we need to implement compress. So compress takes, I guess, bytes to add. Bytes to add merge size. Oh. There you go. That's all it takes, basically. But to add in the child pointer thingy. And a GPA. So maybe they should go vertical anyway. And this guy also takes a GPA. Okay, let's see what compress does. Turn a node n that must be a node without any children into a compressed node. So this needs to be also size 0. Okay. Oh. Hey, Jim. Yeah, no worries. You've not been writing Zig? Man, let me tell you this, Jim. I think that we are now at a stage where the only missing pieces for almost all the software that I've written are the new IO stuff and built-in fuzzing. I feel like these are the only two things that are blockers from Zig. Everything else has been so smooth. So I've updated the tokenizer of one of the languages involved with Zine, and I got a 60% speed up, switching from a while loop with a switch inside to a label switch that basically can do DAF machines, DAF devices, sorry. And it's been amazing. So I want to move everything to this new system, to label switches. The problem is that I don't trust myself really to get this right first try for example, parsers and the HTML tokenizer, because those ones are like pretty complicated. So I'm gonna make mistakes. So I'm waiting for fuzzing, because with native fuzzing, what I can do is use the current implementation as the oracle, and I can fuzz the new implementation against the old one, on top of leveraging the assets that I already have. So I'm waiting for that, and I don't trust AFL++ because LVM keeps regressing that. So that I'm waiting for, and the rest. And then after that, the only thing that remains is, the new IO stuff. Because with the new IO stuff, I can improve Bork. I can improve Zine when it comes to the web server. Yeah. When is the 0.15 release? Right now, it's scheduled for the 11th of August. So, a couple weeks from now. But it might shift. But that's the current release date. Yeah. Dude, with the IO stuff, go better start counting calories, because it's not gonna eat much for lunch anymore. Let's just put it that way. Eventually, not right off the bat, but this new stuff is really nice. Be aware though, Lil Boo, that the new IO stuff will not be in 0.15. Some of the new stuff will be in 0.15, but not all of it. The new IO stuff is not ready yet. It will take more. It will take probably September or October for all of it to come out. Yeah. And you know what? Here's my impression, which you will obviously not apply equally to any single person on the planet, but at least from where I stand, I used to have things written in Go because for web-based stuff it was better, but this margin is really becoming thin. Go still has an advantage, but it's really becoming thin. With the new IO stuff, I think that really the only difference between Zig and Go is how much battle tested is the built-in HTTP server and client. That will be pretty much it. Maybe not all of it, but mostly. No, sorry. This stuff is still cooking. It's in a branch. Which, by the way, you can play with it if you want. There's a branch called async-await-demo. You can check that branch out. You need to build OVM. You need to build the compiler, so that there's some work to do. But you can try a preview if you want. That said, there are parts of the standard library that have not been updated yet to that. And if you look at the development Zulip, you can see that Andrew is working hard on that stuff. But there's a lot of stuff that needs to be ported, and he doesn't have. I guess he doesn't have fuzzing. So like you can see that basically him and other people are testing stuff out, occasionally finding bugs, trying to figure things out, how to restructure. Although I will say it's also a creative problem because some implementations need to be adapted and redesigned to be able to use the new API optimally. And at the same time, the API needs to allow you to do these things well. And so I think that maybe Andrew, while doing this stuff, has also had the opportunity to realize that certain API details need to be tweaked. So I guess my point is that it's not just a, boring job of translating old API to new API and avoiding regressions. There's that. But there's also the aspect of testing the new design for fitness with their real world use cases, like implementation in the standard library of compression, HTTP, and stuff. So it takes time, but it's coming. It's coming. Okay, so must be empty, must be split. And we want to turn this into a compressed node. I mean, you know what? I'm gonna change compress to merge, since we call this stuff merged. And I think this is easy to implement even without looking at the original implementation. This seems very trivial. So we take the old node and we need to resize it. So first of all, const new equals try flex.resize node GPA and then the old void length. The old void length is 0 because this is only, what we're doing here is only for empty nodes. And then new lengths. Let's go. So new lengths is going to be bytes equals bytes.len, ptrs equals 1. And so far we're not concerning ourselves with any data pointer. So we have this. And now all we have to do is copy stuff over. So add mem copy new.bytes.slice and bytes. So we copy the bytes. Oh, wait, though. Before we do this, we need to add the defer. Unreachable. Okay. Const child equals try node dot create GPA 0 bytes, no value dot split layout. And then we do r defer child dot init GPA single. There we go. So this is child. We do child first. Then we do the new stuff. Then we cannot play it anymore. So we do defer unreachable. Then we mem copy the byte thing. And then we do new byte ptrs.slice at 0 equals child. Oh, this is new child. This needs to be renamed like before. Okay. And then we do child equals new child. Child star. And then we do, oh, do we not have the new parent pointer stuff in here? No, we don't. So we're good, but we do make mem copy child field child. Yes. We set the child as the child of this node, which is what we do here. Copy the bytes over, set the pointer, set the outer thing, and then return new. Okay, so this is what merge does. That's it. Cool. Okay, we have implemented merge. We have implemented add split byte. We have implemented. We're only missing realloc for data. Okay, resize for data. So we didn't do much with it, but I think this is it. So, and this is like literally h equals h resize for data. No need for like intermediate stuff. Even here, like what is this? H equals. Same here. Can we take this out then? Yeah, I think this stuff can survive on a single. Oh, this one can. The other one maybe not. Although, you know what? We can catch in a block because we'll probably need to do something like this, and that makes everything easier. Come on. There we go. It's fine. We're a little bit at the border, but it's fine. Okay. So we have everything except, well, we need to implement this. Resize for data needs a GPA. So how does it work? It's just a resize. I think it's literally just return flex.resize node GPA, and void len is n dot bytes dot len. Actually, is it? No, it depends on the layout const. Void len is switch and dot layout dot merge is 1 dot split is n bytes len. So this is void len. And then new lengths. Yeah, the only thing I want to change here is dot value equals 1. Also, we should say assert n dot value dot len equals 0. There we go. And this can obviously fail. So here we're catch panicking right now because we don't have the undo path implemented. This works. And then wait a second. And then if h is key, never mind. I might be misunderstanding what resize for data does. I assume that it always added. So it instead just aligns based on that. Let's take a look at the code that we're porting. Yeah, first it calls realloc for data. And then it says, oh, if h, this is the new h, but we have just assigned it. So it does, if not h is key, then add number of elements. So if it's not h is key, then add an element. Interesting. Then we set the data, set the parent link, and we return. Okay. The problem is the value pointer correct? Yeah, because it's value. Okay, that makes sense. Yeah. Okay, so we have this implemented, all of it. Let's watch build errors. I would be surprised if there aren't any, so let's go through them. Expected type U30 found U size. Okay. In flex line 144. This is what is this saying? Expected type U30 found U size. Yeah. We need to incast it. Okay. Next problem. And now we are back into racks. No field memory function the init in optional. Yeah, I think this is not optional. Never mind. Next problem. Expected type optional, blah, blah, blah. Found type info, we're missing tries. We're simply missing tries. Try node create. Try node create. There we go. Else try node create. No field member function the init in an optional thingy. 218. Yeah. Value of type bool is ignored. No field name slice. Yeah. Sometimes I forget to put the function call. Cannot assign to constant. Maybe suffix blah blah blah. I don't want to make it var though. We're not gonna use next anymore, right? No, I shouldn't say next. I should say maybe suffix. Type info blah blah blah. Does not support field access 297. Yeah, we're missing tries. Oh. Instead of yeah. Expected blah 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 function cannot return error. Merge cannot return an error. Well, it should be able to. Expected W30 found U size, new field LAN. Wait, is this back in flex? Yeah, we're back in flex. 238. Uh, there you go. Expected type void found U size. Oh no. Expected type void found U size. God damn it, man. Oh yeah, actually, now that I think about it, yeah, this line just should not be there because it's the void case. In the void case, we don't write anything down inside. So what's the problem here? Optional node does not support field access. Optional? Why do we think the new is optional? Oh, because resize returns null if it was the original thing. Okay, let me think about it for a moment. Do we ever care about resize? Where do we, somewhere we have an if. Yeah, what do we do with the if? If it's new, then we set it. We update the parent link. If it's not new, we do nothing. Okay. Guess we do or else n here. That works. Accepted type. Blah blah blah. Oh yeah, this is missing a dot star. No, it's not. It's missing an ampersand here. 95 optional node. Okay. Member function expected one argument found 0. Yeah. Expected type, blah, blah, blah. Found, blah, blah, blah. 135. What's your point here? Expected. Oh, because resize returns null. Return try or else n. You know what? I think resize for data should actually return you an optional in line with our order design. So we don't do or else in here. We don't do try. We go to where it's used and we do this. If catch to do. Yeah, like this. Expect to type pointer to use size from use size. Man, this pointer safety, oh my god, this type safety is delicious. If this had not been Zig, if this was C, there is no fucking way that we would have gotten all these type errors to just guide us to success. In any case, we can add more stuff now, and we can test if it works. Because you know these are like the basics, and that it's like great that it works. But let's do something more than that. Let's not just add an empty thing. Let's add cat and I don't know, catastrophe. So let's see how it goes. Get output cat. Expect that not found existing. Then we had catastrophe. Let's do it like this. Catastrophe 100. Then we try to add catastrophe again, and we expect it to be 100. And then we try to add cat again, and this time we expect it to be 42. Okay, let's see how it goes. Watch it fail now. Segmentation fault at address 0x4. That is sad. That is sad. Lil Boo, if you're asking about Jim's project, is a debugger called Microscope. Usescope.dev. I forgot that there's also a website, but yeah, there's also that. There's also a Big Showtime episode dedicated to Microscope if you're curious. Oh, interestingly, apparently everything succeeded as far as I can tell. And the only thing that is not working is this. The defer it's the root the init. This is delightful. we are having an issue when freeing recursively, which I guess would be nice if we didn't have as a problem. But it seems that so far we have passed all the tests before this point. Like if we change this the init to we comment it out, then we're gonna fail because we leak memory. But no, never mind. We're also, let's see, one failed, one leaked. Unexpected result. What is the unexpected result? Expect got not found existing 450. Yeah, they should say not found existing. Okay, so we're reporting the wrong found existing value. That's fine. That is fine. That probably has something to do with the fact that we failed then at freeing. But in any case, we didn't do too bad. So this was nice. We made some progress. I am honestly kind of tempted to stop here this work and switch to something else just for variety. That said, it would definitely be nice to figure out what the heck happened and like stop at a clean state. So here's what I'm gonna do. I'm gonna take a very quick break. I'm gonna go to the restroom very quickly. Maybe get something to drink. Then I'm gonna try to figure out what's happening, why we're failing, and I suspect it's gonna be very easy. Well, I can't say this for sure. We could be fucking something up, but my impression is that we're doing something. There's some trivial error also because look at this. The one that fails is the first one, is the cat case. So let's just make sure to get cat right. And then we can make progress. That said, you know what? The fact that this one fails means that we don't get to test the rest. So there might be more bugs lurking. But at least this first one shouldn't be too hard to tackle. So give me a second. I'll be right back. I'm back. All right, let's see. How do we fix get or put cat? So what's the problem with get or put cat? I guess we want to see where we land, basically, with this stuff. So let's see. Okay. We try a low walk. What will the low walk do? Get from root, try to consume stuff, but this shouldn't be able to consume anything. So low walk should return us basically to pretty much where we were right away and not do anything, which might explain the problem. No, we do set the paralink every single time. Actually, do we? No. While h bytes len is greater than 0, we never enter the while loop because our starting node is empty. We never enter there, so we go here and we say if there's a stop node, what is a stop node? If we were given a stop node, we set it to h. If we were given a parent link, we set it to our parent link, which right now is the root. That is correct behavior. And if there is a split index, oh, check this out. If h layout is merge, then we set it to something. But that is an interesting problem because I think that what happens is that, oh no, we do initialize j at 0. So it does get initialized. It's not like set to undefined originally. So it should be fine if we leave it untouched. So we have I equals 0 and j equals 0. So if I equals key.len, that is not the case. So we don't enter here for sure. If layout is merge and I is different than keylen, and the answer is that it's not the case because the default node is not merge, is split. So we don't enter this case. And then we have else if layout is merge. But we don't enter this case either. So we're at a empty split node. We immediately get in here and we say, is I lower than keylen? And the answer is yes. Is this node empty? And there's more stuff to create? The answer is yes. So we do enter here. So what do we do here? We select the merge size. We do merge. We set parent link. We set parent link to pointer slices 0. Maybe, but then that means that merge returns n, a reallocated n. Okay, we need to take a look at what merge does. In any case, so in theory, we do this. Then we go down here, which extends nodes, and then h equals child. Okay, so yes, that does make sense. Yes, that does make sense. That works for me. Yup. Okay, so then we loop again. No, we don't, because I should be keylen. I should be keylen. We don't loop again. And we say, if not h is key, increment r.elements. Why do we think that h is key? Well, because we did resize for data. That's the problem. Yeah, like what? Yeah, what is going on here? What is going on here? So yeah, we are definitely doing this wrong. Let's take a look again at this final part. So we reallocate for data. We get a new age. We set it. And then we say if not h is key. But I think the question is that the point is that if we got down here, we need to take a look at the original resize for data, because there might be some other assumption that we don't know about. But what I'm thinking is that if we're doing this, then the answer is no. The answer is always no. Like, why is this like this? Shouldn't it always be this? That's one fail unexpected result when adding catastrophe. We expected gob found existing to be true for catastrophe. I guess the second time around that we try to add it, right? Let me see if this test makes sense or is it broken. Not found existing the first time, but we expect yes found existing the second time, which makes sense. We do expect to find it. This should return true. I'm actually surprised that it does not return true. Also because catastrophe is, in this case, should be entirely handled by our case up here. Like Rack's low walk should find it. Catastrophe I equals 1, j equals 0. Nope. That should not be it. So when we try to get catastrophe after adding cat, we should get all the way up to CAT. I should be, oh no, actually I is correct because it should be, so the first time we add catastrophe, it's 0 would be stopping at C. 1 means stopping at A. Wait, didn't I guess it's the only thing that matched, but then why is T 0? Why is J 0? You know what? That might be correct. Or rather, this might not be wrong, but this is definitely wrong. This is somehow failing to continue matching. Let's see why we fail at matching in low walk. Do we not write out our stuff? We do. Excuse me? We are never getting in here? So we want to add cat. We walk C. We walk C dash C in cat split. Byte is edge bytes slice. No, we're definitely doing something wonky. We're definitely doing something wonky. You know, also what could help? Something that like a recursive print of the tree. We need that. That really helps. That really helps. I think Rex has a some printing code. Maybe we can see if we should steal it or make our own. Ah, man. Yeah, we feel like right away this is so weird. So we try to add empty string, fine. We try to add cat, and we say walk cat split. Because the first time we walk nothing. So this is us trying to add cat a second time. Is this how it works? We try to add cat twice and then catastrophe? No, we add cat once. So out of curiosity, if I comment this out, if I comment that out, then we try to add cat once. So this second time we try to add catastrophe. And then this says that we're walking cat split. We definitely should not be walking cat split. What are you smoking? Hmm. Wait, I'm being dumb. No, it is correct. It is correct. The second time, right, we are walking a node that contains cat. Right. It is correct. The fact that it's split is not correct. This is not a split node cat. This is a merged node cat. So why are we leaving it split? Well, this is what we're failing at right now. Here, when we're doing merge, we're not setting the layout correctly. Yeah, we are resizing. Oh, that's entirely it. We are resizing, but we're not setting the layout. It's a post condition. Layout is merge. And bytes.len equals bytes.len. These are the post conditions. Okay, now we are messing something up. End.bytes.len equals bytes.len. Why are you not in agreement with this statement? Oh, because we can't assert this on n. We need to assert this on new. Never mind. We can't put these asserts there because of how we structure the code, but it's fine. So let's see. We add cat. Then we are trying to add catastrophe. We see cat, which is a merge node. We walk C, we walk A, we walk T. And then we don't see anything else. It's fine. And then the second time, oh, Rook, we're passing the test now. We're just leaking memory. Okay. That works. So we can add a second loop check for catastrophe. Source and destinations have non-equal lengths. This is cool. Okay, so we add cat, and then we try to add catastrophe. I should probably print that we're trying to add something. Okay, so we're adding empty string, adding cat, adding catastrophe. We find cat merge node. Then we get into our algorithm and we see that we are at catastrophe with index I equals 3, J0. Okay, then we add catastrophe again. We see cat. And then we walk astro. What? We are walking astro? Excuse me? Why is this not catastrophe? Why did we not put Ophi in here? Well, actually, astro. What? Why does phi not fit? Uh-oh. We have some competition that truncates these things if it's too big, but I mean, excuse me? Oh, it's because of these keylen minus high, huh? Merge size 8, I equals 3. 1, 2, 3, 4, 5, 6, 7, 8. Correct. Then why the fuck is it just Astro? What happened? Oh. Oh. It's a size, not an end. I do this all the fucking time. There we go. Astrophy. Success. So we see Astrophy, and then we panic somewhere else. Okay. Well, I made some mistakes, but they're not terrible. It's actually minor stuff. Easy to find. Source and destination arguments have non-equal lengths. Rax 257. In maybe suffix. If there is a suffix node. What remains of the original compressed node after the split? The split happens at index j, doesn't it? So just finished listening to your talk. How can I get into this programming coming from the web and a backend background using Zig? Okay, MLX. Well, thank you for spending time to watch the talk. So, okay, more tactical advice. 3 answers. 1, find Zig learning materials. It's not too hard. You go to the learn section on the official Zig website. You have the language reference, the standard library documentation, more documentation about the build system. Then there is some introductory stuff. There's also online learning resources. These guys, don't ignore them. They're good. They're useful. So there's a community made book from somebody in the community. There's Zig.guide, which is a website that is based on like use cases. Like for example, oh, I want to see how to open a file from disk. Go to Zig.guide. It will guide you on a use case based manner. Ziglings is, if you find the syntax of Zig complicated to get used to, Ziglings is a series of tiny programs with mistakes in them. And in the comment, in each one of them, there's a comment that tells you how to fix the program. And so you basically run Zig build, the first one will fail, you fix it, run Zig build again, the first one will succeed, the second one will fail, etc., etc. And then there's also other online resources. So number 1, find resources. This is your starting point. Number 2, there's also other stuff on the internet, but this is your starting point. Number 2, find a project that you have never attempted before that you wouldn't be able to pull off with a higher level programming language. So for example, a static size generator, I guess, but also, have you ever implemented a tiny programming language? So for example, there's crafting interpreters. You can do this with Zig. The book does not use Zig, but you can translate. So I guess my point is that this is interesting, but you probably want to get this type of stuff where you translate from other languages to Zig. You can totally do it, but you need to have a modicum of experience using the language first, obviously. So crafting interpreters is one. Another one is ray tracing in one weekend. I did this the other day. So you can even find recordings of me doing this, for example, in case you're afraid that you might get stuck. There's that. I also did operating system in 1,000 lines. This one uses C, and I translated that to Zig. This one uses C++, and I translated that to Zig. well, setting aside these like prepackaged experiences, which are good, I think they're really good for learning purposes. But then you also have, for example, have you ever tried to do anything with audio? Nothing too complicated, but for example, an echo program where you open your microphone audio stream, you capture it, and then you play it back in your headphones. Um, you will find that it's surprisingly complicated to get to that point. There's a lot of stuff in there in between. So uh, this is suggestion number 2 then. Find something that you've never done before. Try to do it with Zig. Obviously, you need to be careful because you can't immediately aim for something super complicated if you've never done memory management. So you kind of want to get a little bit of experience with the language, you doing something simple, hello world, simple exercises. You have some of the online materials that I linked earlier that will guide you through some basic stuff, showing you Zig specific concepts. And then you branch out to something a little bit more serious where you will have to translate to C because you will not be given to Zig because you will not be given the Zig source code. Suggestion number 3, and you should do all 3 in all at once, right? So you shouldn't do only one of them. So find learning materials, find a project that you never done before. Suggestion number 3, join a Zig community. Go to zigline.org, go to join a community, and join a community with other people that are programming in Zig so that they can help you where you don't know how to do things, so that you can help others once you start learning how to do things, and so that you can also read other people's code so that you can learn new patterns when, whenever somebody more experienced than you shows something cool. Do these 3, and there's chances that you might have a good time. Also, related to this last point, Zig.day. So if you go to Zig.day, these are like in-person events. There's a bunch on the West Coast, East Coast, empty for now. There's one in Milan. And a Zig Day is a full day event. It's like a meetup, except on a weekend, and it takes the full day. And the idea is that you join and you do collaborative programming for the entire day. So basically, the way it works is that people meet in the morning. Everybody talks about what they want to work on. So let's say that you started your own static site generator, and so you say, "Yeah, I'm working on static site generator." You introduce yourself. So you say, "Hi, my name is something something, and my name is Mr. Malex, and I'm working on static site generator or a echo program for my microphone." Everybody does this, and then after that, people break up in groups because the idea is that maybe you did have a plan. Well, actually, you can show up without a plan, but maybe you didn't have a plan, but you heard that somebody else is doing something you find more interesting, or they seem like they could use some help and you know how to help them, so you can join other people and other people can join you. And then, you do this for the rest of the day, and then at around, 3-4 p.m., then people group up again. You just talk about, anything that you made, any progress that you made, and then that's the end of a Zig day. Lastly, I have a YouTube channel where occasionally you can find something useful. It's called Zig Showtime. For example, this one I think you might find useful because it's about the build system and everybody asks these questions. Or send. There you go. These would be my recommendations. No problem. So maybe prefix contains data from the start up to J not included. Then we have the split node. Where do we set the split node? At the very end, I guess. Um, wait, where do we set the split node byte? Oh, there we go. So we set the split node contains j. The prefix node contains from 0 up to j not included. The suffix needs to contain starting from right after j until the end. Why do these two lengths disagree? H byte slice j plus 1 to the end. The length of the suffix is, let's say that this is 10 bytes and j is index, let's say 5. So it means that 0 through 4 go into the prefix, 5 goes into the split node, and 6, 7, 8, 9, and 10. Sorry, length 10. Yeah, it's a length. Length 10 go into the suffix. So indices 6, 7, 8, 9, basically, go into the suffix. So here we're doing 10 minus 5 minus 1, which is 4. We can even do it like this. I guess we want to read these lengths. Suffix length 97. Bytes len, yes. Suffix len, no. Uh-oh. We are reading some data wrong, and that is a problem. Ooh, is that a problem? That is a problem. We think 97 is not good. Is it undefined even? 97 to hex. If it's AA, it's not good. 61. Okay, so no, it's not AA. We don't know what it is. Actually, maybe it's an A. Oh shit. 97. Is that lowercase a? Oh, you know what? Maybe we can manipulate this. This would be funny if we can manipulate that easily. Oh shit, yeah. 97, 65. Oh, fuck. Do-do-do-do. 65, uppercase A. 97, lowercase a. Er, er. Er, er. Er, er. So this is not a problem in our Rax implementation. It's in our flexible array implementation. Hmm. How do we create suffix? Maybe suffix. Yeah, actually, how are we fucking this up so much? Maybe this is the problem. We're fucking this up so much. So suffix len is 7, bytes len is 7. That already seems problematic because this should be 8, I think. No, it's actually fine, maybe. Maybe it is fine, but in any case, how does he go from 7 to that? It's the slice function that is broken. Yeah, it needs fast dicing. Yeah, it does. I'm still at a stage where I need to reason about this and learn how to reason about it correctly. I'm kind of there. I'm well positioned to understand it, but well, no, actually, you know what? No, I think you're right because it's not really a problem in the Radix 3 implementation. It's a problem in my abstraction. Like, how am I fucking up the pointer math like this? So what do we call here? Here we call node create. So we just created a node. So again, yeah, where do we fuck this up? Because at some point we override it somehow. I guess it's this. This is the kind of stuff that but this is writing in prefix. No, never mind. It's suffix. And this is like the first write that we're trying to do to suffix. Maybe suffix. How is suffix corrupted from here to here? Although maybe it's the slice math. Yeah. You know what? Len is correct, and I bet you that Len is gonna be correct also in here. So here, no, it's bytes len that is already corrupted. Never mind. I thought it was slice, but we're not even calling slice here. We're calling bytes len, and that is corrupted. But how is this? How is this working? How is this possible? Because we're looking at different variables. What? I think we might be looking at something else that I'm not thinking. So because the first time that we do catastrophe, it's fine. It's the second time that we had try to add catastrophe. The things go wrong. Oh, you know what I think it might be happening? So key is catastrophe. Sorry, here we're adding catastrophe. So here we're adding catastrophe the first time. Here we're adding catastrophe the second time. Oh, there we go. Now I understand what's happening. So what's happening is that we see cat, we match it. We see astrophe. But then why are we not walking astrophe? Here's the problem. We're not walking astrophe, and then we start fucking up other stuff. But this second time, we should not be adding anything. This second time, we should just be walking the tree. So the question is, why is this second walk stopping early? Okay, now I see the light. And it's something wrong with the implementation of rack slow walk. Because we're not walking stuff that we should be walking. So here we're saying, yes, we're walking astrophe, which is a merge. Then why are we not doing it? We're entering here, but we're failing. Why? Oh, because this is not key from 0. This is key from I. Let's see if the other rack slow walk had this, and I mean, one way or another, it has to have the correct implementation. But yeah. So low walk. Yeah, it's doing VJVI. Okay, it's implementing it in a different way. So yeah, I messed up because we loop and we mutate I, and I is where we start from. And bytes always starts from 0. Yeah, that's fine. Panic loop over objects with non-equal length. There we go. Then we match astrophy and we catastrophe everything. There we go. And then we can do cat again. Still succeeds, and we're only leaking, so take this out. Yeah, success. Okay. There's a bunch of spam printing going on, but setting that aside, we succeed. So we're dealing correctly with this stuff. Okay. So this is good. This for loop is not great. Really not great, but okay. Okay, we reached a happy place where everything works. So what are we missing? We are missing. So we have implemented the main algorithm. We have implemented the low walk. We're missing search. So we're missing Rax find, and we need to implement Rax remove child, or like sorry, Rax remove. Yeah, we need to implement Rax remove. And once we implement Rax remove, we're also gonna be able to implement correct rollbacks in case of out of memory or the rest of the tree. And we're gonna be in good shape. Yep. Yep. And so far so good, actually. I hate this for loop though. I want to do it, redo it. I wanna do it like the C1. Yeah, J starts at 0, gets incremented, and the condition is that J and I are within range. I guess we could loop. Well, while I lower than key.len and J lower than bytes.len, I plus equals 1, J plus equals 1. Then we do the comparison. We say key at index I different than bytes at index J. Break outer. Hmm. Everything works. I don't know which version is the better one. Let's remove this. I think this one is better than this one. I'm gonna keep this one. Okay. Cool, cool, cool. So we did some progress with Rax. I still have about a couple hours more that I can work on stuff. What do we work on? I might be interested in moving more tokenizers to the new label switch syntax. I might be interested in that. But I would like to do this work kind of all at once so that we can benchmark. But I guess it's fine. That's not a problem. Yeah, let's start moving something else. So we have a Ziggy tokenizer. We have a uh, we have the HTML tokenizer. That one though is complicated. We can do Ziggy though and see where that leads us. Yeah, let's do the Ziggy tokenizer. I'll be right back. I'm back. Okay, so you know what? Before we switch, I realized that we want to do another thing. The original comments spoil us. They tell us that the main cases to be thinking about is, for example, let's see. Uh, 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 uh. So here he's showing this word, annibalesco, and then annientare. And that's case one. And then there's another case with the same starting word and then a different one afterwards. So let's test all of these because they should show us, they should stress all the code paths at least once. So let's do that. So this cat stuff, fine. Let's have another one. So I think it's more like this, I think. Every test needs to do a full cycle. So we can, I guess we can try to do it again. Yeah, there we go. And then we try the second word, which was annientare. So we expect to not find it. And then we do mm, no, like this, right? Also here, this is value pointer. Okay, so with this, we should be testing the original word. Honestly, this doesn't even matter. Although it's probably not bad to have at least once. I guess I'll keep it. And then we have the second word. Let's see if this works. Undeclared identifier R. Excuse me? Root 505. Wait, what? Okay. What happened? Incompatible types, time int, and use size. Yes. Hello, name pointer. There you go. So we got a failure. There we go. I knew there was more. That suffix len is spicy. What's happening? It's spicy indeed. So, okay, we try to adding a Nibalesco. Merge size 11, adding. Okay, so we do it once, it works. We try it again. We match everything immediately. That's the end of it. We try to add another word. We try to match with this, and we match a prefix. So we at the E, which is in J index 4. Are they supposed to match? I and J. 1, 2, 3, 4. Sorry, 0, 1, 2, 3, 4. Are we sure that I isn't supposed to be one less? No, because we always increment them in parallel. So never mind, they are supposed to be the same. Okay, so then we need to split on E. E needs to become a split node. This is the prefix. This is the split node. This is the suffix. And somehow we fuck it up. And we end up here with everything fucked up. So apparently this was a problem all along. We were just not getting there with good reasons, basically. And it seems that here it's kind of the same problem. And this boy is a big number. And I bet you that these 4 bytes are letters. These 4 bytes are letters. So let's do this. To hex. I might be wrong, maybe. Let's see. 10. Hex 10. It's not. No, these are not letters. Okay. So let's check that we're entering the algorithm with the right preconditions. We should be okay. We should be entering here std debug.print insert. Let's just say algo1. Algo1 with I equals something and then j equals something. Algo1 I j equals 4. Yeah. Okay, so we are indeed entering here. Save the next pointer. Set the length of the additional nodes we will need. Suffix len is 6. 1, 2, 3, 4, 5, 6. That's not true. It should be only, it should not be 6. It should only be 4. Well, we get complete garbage down here. So yeah, you know what? That's why we're getting garbage, because we are undercounting and then we are mem copying more than we should or something like this. H bytes len 11. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why do we think that this is 11? Oh, right. Anibalescu is 11. You're right. The other word. You're right. I'm dumb. Right. This is 11. Yes, yes, yes. Of course. Thank you. Thank you. Right. This is 11. Okay. So split node is key j equals 0. And the answer is no. So the split node contains 1 byte, no value, split layout, then maybe prefix. Okay, so suffix len is not 0, so we'll create this guy with suffix len as the argument, and suffix len is oh, right. So here's the point. Right. So this is why this is like this. Because right now, oh, this explains what I fucked up. Here's what's happening. Here is what's happening, I think. We're splitting this. So the suffix is not like the new suffix. The suffix is the old suffix. So what we are like placing in this, what we're placing in the prefix is from H bytes, and that is correct. What we're placing in suffix is also from H bytes, not from key, but that is definitely what we're doing. So yeah, this is happening, but it's still not okay. Or rather, this guy, I think it's okay. So it's length 11, j equals 4. Let's double check. 0, 1, 2, 3, 4. So B. Yeah. Plus 1, A. And this is where we start from. And so bytes length is 6. 1, 2, 3, 4, 5, 6. Okay, so yeah, this last part is computed correctly. It's just that suffix len is completely corrupted. And that part is the part that surprises me. I don't know how it is possible that here somehow suffix already contains corrupted information, because in theory, let me double check. Where do we create suffix? In where's suffix? Maybe suffix. In theory, we should not have this problem, because for us, suffix is a merge. It's a merge node. We call flex create. We set the layout. What else is there to set for us? Nothing, because these values all get set by flex create. We can actually print this. No, we kind of can't because we have garbage in there. But we no. I take this back. The struct is fine. The struct should be fine. New node, layout merge, value length 0, bytes length 6, pointers length void. Oh god, the fact that the void value is printed like the void type, that's a debatable choice in any case. And yet somehow, once we get here, it's corrupted. How is this even possible? Maybe prefix, maybe suffix. I guess it has to be possible if one of these rights goes out of whack, but it shouldn't. We have bounce checks on all of them. We most definitely have bounce checks on all of them. It's almost as if the value that we're obtaining from this unpacking is bogus. That said, though, it is true. You know what we can do? Here's what we can do. I can take this stuff and paste it afterwards. We can change the order in which we do these things. And I think they don't have any data dependency between them. So let's see if this still is borked or if something else borks. I didn't follow everything, yeah. But does your Anibalesco would split into Ani, B, Alesco, and then you create a left node and try. No. The way it works is that you do Ani is the common prefix. Then you have a split node that contains B and E, and they're like branching choices. So the algorithm will match with will try to match with only one of those letters, any of them, instead of trying to match them all in a sequence. So you have Ani, BE, and then Alesco and NTRE, TARE. So so you're roughly right. It's just that you need to be aware that there is a branching node in the middle with the single characters that we're branching on. Oh, look at this. Look at this. Now suffix is not corrupted, but prefix is. Now suffix is not corrupted, but prefix is. So somehow writing prefix is what borks suffix. And writing suffix is what borks prefix. How is that even possible? I should write this stuff in Valgrind, and maybe Valgrind will tell me where I'm fucking shit up. But the problem is that there's a bunch of metaprogramming that also doesn't help. But still, really. So what are we doing here that is dangerous? We're writing through parent link, but parent link should not point at us. So we should be fine. we should be fine. But I guess I could comment out the parent link parts, although no, that is kind of a problem. I know what the answer is. I know what the answer is. I changed these conditions slightly from the original source code, and my change did not maintain the original semantics. Yeah. Okay, check this out. So here we do this, but here we do this only if j equals 0. And yeah, that's part of the problem. So this is only if j equals 0, and this is if not j equals 0. And this is the prefix initialization. This is the prefix initialization. Although maybe prefix, but prefix is based on j being different than 0. So no, never mind. You know what? In this case, the logic seems to be 1-to-1. If j equals 0, then we don't make any prefix, which makes sense. And so then down here, unwrapping prefix is the same thing. And then for the suffix, we only create a suffix if suffix len is different than 0. And so this also should be the same. Oh, but these are, I think these are, wait. These are flipped around. Maybe, let me double check. Here, if j equals 0, and here, if suffix len equals 0, we do null. I think these are kind of the inverse. Let me double check. So trim, by the way, also trim len is j. It doesn't get modified, does it? Trim len. It doesn't even get modified. But here we switch, well, here we branch on trim len, and down here we branch on j, which is a choice, I guess. Yeah, so I fucked up something in this logic. Okay, let me double check again. So we create the what I call the prefix node only if j is not 0. Because if j is 0, there is no prefix. Then there's the suffix based on this. And so, oh, right. Right. So here is, if there is no prefix, then we do this. If there is prefix, we do this. I flipped it around because I'm packing an optional. So yeah, if there is no prefix, then we do this, which we can also double check. We say if the node is key, Rex get data. Does this apply side effects? It does not apply side effects. Okay. Please. So, so this is fine. And this initializes the node, the prefix node. And in the other case, we do the same. Yeah, it's just, why are these in this order? It's kind of curious that the prefix starts with the case where there is no prefix, and then it does the case where there is a prefix. But for the postfix, it does the opposite. The case where there is a postfix, which I call suffix. But somehow the prefix initialization is messing stuff up. Let's put in these pointers. Yeah, they're very close. So the prefix is stored at this address, and the next node is 16 bytes below, right? Yeah. It's 16 bytes below because we think that this guy should be big 16 bytes. There may be some other alignment situation, but we have 4 bytes for characters. What's the size of the header? It's 32 bits, I think. So 32 bits, that's 4 bytes. These guys are another 4 bytes. We are well aligned, so there is no need for padding. So these are 8 bytes. So 8 plus 4, 12 plus 4, 16. So these distancing seems appropriate. It seems very, very appropriate. Then this guy here, I actually don't really care about how big this is. Is this guy? Also, wait a second. Where's this split node in all of this? Where do we put it? Oh, the split node gets created before any of them get created. So that's fine. You know what? Let's split also the split. So where's split node? Okay, 10, 10, 20, 30. This guy is much smaller, but I guess because of padding and alignment, we need to waste some bytes. That's fine. So all these things do make sense to me. I don't see how modifying prefix would clobber suffix, but this is what's happening. So this is 100% what we are experiencing. So this kind of has to be it. It's probably, I don't know. Let's see this. Oh fuck! I found it. I know what it is. No, I don't, because it's a pointer. God damn it. I thought I did, but no, I don't. Okay. Using Zigup is any good for a starter? Yes. I mean, you can start with just downloading Zig and doing the work manually to place it in path. But if Zigup works for you, use it. I use it to switch version of Zig. But you know what? It's not. It's also pretty handy to update Zig. You just do Zig master, and it just fetches a new version of master branch. Or you can do like Zig up 0.14.0, and it gives you 0.14, for example. So you know what? Yeah, it's not a bad place to start. Okay, prefix. Can we do it like this? If I do slice, will I get everything that I need? Cannot format slice without a specifier. SX. Okay, give me S maybe. Oh no, because S is for string. B64 or any. Okay, give me any. What do you think of any? Slice is this 170, 170, 170. So the slice is big 4. And we write 4 things to it, I guess. If prefix is key, could it be key? It's key if H is key. Okay. I guess what we can do is print what we think suffix suffix is. And J is gonna be 4, right? Yeah, J is gonna be 4. So this is all we do. Like this is literally all we do. And then we go into the suffix. You know what? Give me the pointer of suffix. Okay, suffix is still the same pointer. We are not receiving a weird pointer at this point. Suffix len is completely clobbered for some reason. But at least suffix is fine. And also this value keeps changing. Why does it keep changing? Because it's garbage. It's almost as if we do not write byteslen when we allocate this node. Okay, this seems weird, but it really seems this. Except that it's not the case because we are printing whenever we make a new node. And we know that when we make this node, which is going to be the suffix, it's set correctly. It's fine. It's fine. And it's fine here as well. But here it goes insane. Start to print the node, I guess. The whole struct. Yeah, len has been corrupted somehow. How? How is this possible? Maybe it's one of these parent link writes things that are problematic. But even then, why are the numbers changing every single time? Well, this location does change. So maybe this number is a pointer. You know what? Let's print suffix len in hex. And then we'll see that it's going to be it's the pointer or something like that. Oh God, yes it is. Found the problem. Found the problem. We're writing somehow. We think that is where we think that is where a pointer to stuff should go. Even though no, it shouldn't. Okay, so we're starting to see the light. And we are actually placing in here specifically the pointer of split. So somewhere we're assigning the pointer to split. Like here, for example. Although we should not be entering here because, wait a second, what is going on? Oh. So this might be sus. This that we're looking at might be a SAS operation. Maybe let's print this pointer. Hmm. So prefix.next is, oh no. We think that prefix.next is a this pointer, but that's where suffix is. This is wrong. Why do we think this? I'm aligning forward using the wrong type. Somewhere I'm aligning forward, not using the child type of this field, but using something else, something wrong. Next line is void, var. Bytes len is 4. Why are we aligning forward this much? Why are we aligning forward this much? Let's see. We start by pointer casting in the parent type. We start the offset at where the struct ends. For each field, we align forward based on the alignment of its type. What is T? Ah, there we go. Here's the stupid shit that I'm doing. Oh no. Man, am I dumb. This is not a line of T. This is alignment of the field type. Of course it is. No, it's not even that. It's field dot type dot child. Let's double check that we don't fuck this up also elsewhere. Oh god. Field dot type dot child. Oh no. Oh no. It's the child type. Okay, let's see what happens now. 20, 40, 60. Where do we think suffix next is? Sorry, prefix next. Prefix next, we think that it's at 50, which is within prefix and before suffix. So this is good. Okay, we made some progress. And now it complains that allocation size 17 bytes does not match free size 24. Yeah, when I'm multiplying by size of the field, watch me do the same stupid thing again. Size of. Okay, so no, here I'm doing it right. Size of type dot child. But am I doing it right? Let's see, size of type child. Size of field type child. Yes. Type child. Field type child. Field type child. Field type child. Type child. Type child. Type child. Okay, it doesn't seem that we're doing too bad with this. But now my math is apparently out of whack again. Something is fine, something went out of whack. I guess we need to start by looking at current size. Actually doesn't matter because we're not even using it. Let's start with the slice. Yes, slice. Start from these bytes. We find a field. Then when we align forward, this is this usize. Round an address up to the next or current align address. Yes. Okay, and we'll use alignment of the current field type and then the definition child. Yes. And items are not of type T though. Well, no, they are. In this case, they are because this is when it's us. Okay, so this is fine. This part is fine. Then if it's not us and we go here, if value len is different than void, if value len is different than void, right? Because this is basically saying we only go here if Yeah. So this should be fine. Value len. Okay. Create. Size starts with size of p. As we loop. If it's not flexible, we don't care. If it is flexible, we complain if length doesn't have a corresponding field. And then we align forward based on the alignment of this child. And then we have size of this field times size of field dot type dot child. That was missing. That was important and was missing. Yeah, kind of important, huh? Then data. And then we set these fields. Okay, so this is good. Destroy. We're computing the size. Every time we align forward based on type child, every time we add, we multiply by the size. Maybe that was the only thing missing, maybe. Let's see. Or not. Type E1 cannot integer value. Where is that actually? 132. Yeah, we did. How did we do this? Because somewhere we cast this stuff to usize, basically. Yeah, we do it like this. Wait, what is the question? Error. Type U1 cannot represent integer value 8. This guy is the U1? No, this is 8. I'm guessing this. Okay, no, this is what returns 8. And then for some reason, we think that this is a U1. Oh, ooh. I know what's going on. Oh, this is horrible. What's happening is that we are creating like a bit of a generic explosion by having lengths be any type. So the people that were suggesting like a couple days ago, they might want to generate lengths with compile metaprogramming and force it to be that way. They were right. We need to do that to avoid code bloat, and we're not doing it right now. And that's causing things to be a disaster because of that. So length should not be an any type. Length should be a struct like just lengths of a type. And that would solve this problem. And it would solve a bunch of other problems like what we're doing widening here. Because we could just do value len. Yeah, we do it in a couple of places where we could get rid of it. So should we do the metaprogramming to make this happen? I think we should. So what am I doing? IDX is it doesn't matter because the comp time. So what we do is inline for fields, we do this. We do the user check. Has to be flexible. If it's not flexible, we ignore it. If it's flexible, we do buff at IDX equals name equals field on name. Type equals field dot type. We want the len field type. How do you do that? This. So this is the type. Then default value ptr equals null. No default value for any of them. His comp time is false. Actually, is alignment is of, yeah. This is it. We're back. Okay, never mind. Okay, so we make a struct fields equals buff 0.idx. Unless it's in a struct. Oh, you can give it decals, but I'm guessing they're not accepted. So just layout equals, I don't know, dot normal. I don't know what little layouts are. Out. Is tuple actually true? Well, no, false. It's not tuple. Fields, decals. Is that what we're actually, is this what we're trying to give it to it? Yeah, well, that has to be it. Okay, how are we doing with this? We still have this problem, okay. So let's use lengths. New lengths. So resize takes in new lengths. Nobody else does? Oh, this guy does. Let's see how we're doing. No field name len in struct built-in type struct. Type complaint meme has no members. Oh. Expected type void found comp time int. Right, except for when they have void. So we want to respect that, and when they have void, it's just use size, I guess. Okay, no, this still causes that problem, but I think this is fine. At least we have like, yeah, it's stable, and that's good. So that is good. Lengths. Where is the problem happening? I can't find it. 186. Oh, wrong file. What? 163. What am I saying? $163 of this? No. What is going on? In flex. Okay, let me try again. Missing start field bytes in root. And then this says flex 163. But 163 is file modified by an external process, use W to override. Oh, fuck. Here's the problem then. Oh, okay. I think I can get it. 163. Okay. Okay, now we're back to errors in fax. Missing start field bytes, 186. Oh, right. This is a good point. Fuck. So the idea of doing this, the problem is that if we do this, then either we give default values, so we have to make them optional then, and the absence of the number means that they can omit it. And then the logic is that if the field is it's not more like it's not really about the field being present. It's more like the field is always going to be present. It's more like is the value null or not. Okay, that's fine. That is actually a reasonable implication of all of this. So T is not really that, but it's optional. Optional. Default value pointer. How do we do this? As pointer to optional T. Null. Ampersand. This is kind of a mindfuck, this thing. Sometimes the reference requires optional U1 to have a well-defined layout. Oh wait, I'm optionaling things too much. You know what? I think we should take this out and then do the optional here so we don't go insane. Okay, let's see what the problem is now. Error expected field type U size on optional one. Okay, now we have to adapt the code to account for optionability. So here that we look at lengths, more than caring about the field missing, because this cannot happen anymore. More than that, But wait, this is create. So the check has to be there, but it's about nullness more than anything else. So it's this const. It's basically this. Fill in or else. Panic. No, it shouldn't be panic. It should be more like an assertion that it's not null. Hey, Loris, just wanted to say I loved your talk from Systems Distributed. Thank you. Thanks for giving the talk. Thank you very much. I hope that it inspired you and hopefully some other people to look at programming differently, because that happened to me. Like I used to just do, I don't know, Python and well, you know, let me put it this way. I studied computer science and I always thought of myself more of a scientist than a engineer. Because for a long time, well, not long, super long, but for some time, I dabbled more in the sciencey aspect of it than the engineering side of it. But then I got involved with Zig, and it turns out that no, it's I can do engineering. It just requires effort. It just requires a different kind of effort than the type of effort that you put into like sciencey stuff. But you can do it, and that also made me realize that then if you get serious about this, then you just cannot you cannot stick with JavaScript and Python and Go and Java and C#. They just don't cut it. You need to go down and you need to get control over everything. And man, once you do not want to come back. I now have a control over what I'm doing that I am never going to give up. There's just no way. I don't want to anymore. Because it's so frustrating. Because the point is that you think maybe, well, but you know, you have to put a lot of effort, and then it's nice sometimes to like let go. I don't want to, because I know that I will be at some point annoyed that I want to change how something works, and I know that it can be done in theory, but I'm in a situation where I just made it impossible for myself to do it, and I wasted a bunch of time writing some high-level code that now I either keep imperfect as is, or I have to rewrite again from scratch in order to actually unlock what I need to. Let's see, I've been slowly learning Zig. Nice. You're finding myself having to Google things like how to convert a string to int, etc. That makes sense. That's fine. If you want one suggestion, consider doing this. Or actually, let me give you that more in practice. So here's what I know, and I can share my mental model for this. The way this works for me is this. I want to convert a string to int. So you want to parse a number from a string. So the parsing stuff in Zig for this type of thing is under FMT. FMT deals with serializing, well, formatting like a number to a string and vice versa. So in FMT, and look at what I'm doing. I have the SCD namespace open and I do go to definition. So I'm using the LSP feature. And then I do for search pub function. And this gives you all the things that you can do. So for example, you have format, print int, digits 2, alt, parse int. This seems interesting. Parse int with generic character seems interesting, but parse int is probably what you want. You can read the documentation, and it tells you what it supports. You can read more, parse this, chart to digit, buff print, count, unlock print. So my point is, read the standard library source code. And that's a good suggestion in general, but more importantly, you don't have to do that like necessarily in a deliberate way. Oh, you know what, tonight I'm gonna sit in bed and instead of opening a book, I'm gonna open the Z standard library and read, I don't know, a chapter from it. No. Make it easy for you to access though, and don't treat it as something that you cannot decipher and that, you know, it's some kind of impenetrable thing that for you it's impossible to understand. It's not. Not all of it will be trivial to understand, of course. but like std dot, I don't know, mem. Let's see what's in mem. Pub function, and you start looking at it. You can even do start of line pub function so that you only get the top level stuff. So copy forwards, copy backwards, zeros, sort. For example, where is sorting? Well, some of it is in std mem. Order z less than equal. Comparisons of memory chunks, which also applies to strings. For a non-fully Unicode aware in definition of string, you can do with just stdmem equal index diff span slice to blah 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 len index of sentinel all equal blah 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 blah. So this is great to make it easy for you to do. So I want to make this an assertion, but I also want to print an error message for the user when they mess this up. Yeah, no problem. Yeah, that said, it takes time, of course. If you want another suggestion, you know what? I'll give you the 3 standard suggestions. Suggestion number 1, find learning materials. Official Zig website has all the, well, most of what you need. So you go to zigland.org, go to learn section, language reference, standard library documentation. The standard library documentation is good to take a look at, but that shouldn't stop you from browsing the source. Getting started. Also, online learning resources. These guys are good. Like Zigling, Zig Guide, for example, helps you with use cases. Like you click standard library and then you say, oh, I want to open a file. How do you do that? File system. I want to parse JSON. This is how you parse JSON. I want to do formatting of my numbers. This is how you format them. Wait, how does the hash map work? Here's how the hash map work. So it's based on, you know, the standard stuff that you normally want to do with the language. Then also the other ones are good. There's book made by a community member. Ziglings, if you are having trouble understanding Zig syntax and you want something that has a smooth learning curve, getting you used to it, that would be Ziglings. So suggestion number 1, get learning materials. Suggestion number 2, find a project you never attempted before. Could be a static site generator, could be something else, a parser, a ray tracer. You know, you could do this, crafting interpreters. It doesn't give you Z code, but you can translate. I did a couple of days ago ray tracing in a weekend, and this gives you C++, but you can translate it to Zig. And if you get confused and you're not sure, you can go here, youtube.com/, well, I'm going to search, I'm not going to type. In the bar, Zig Showtime. Look at Zig Showtime and check this out. I did the ray tracing in a weekend stuff. So you can see me get stuck. There's another one, operating system in 1,000 lines. I also did this one. You can also find that one on YouTube. There's also the code on GitHub. But it's cool to do this stuff because it doesn't take long. And you know, these are well-packaged experiences. So they help you make sure that you have well-spaced sub-goals and you make progress and you don't get stuck. So these ones are all good. So, but you don't have necessarily to do this stuff, these specific ones. So when you get as you're getting started, you probably want to start with something simpler. So like, for example, re-implementing a simple CLI tool that you know of and you make your own version of it. But then once you get used to Zig a little bit, then you can start doing this stuff. And there's also other stuff, like, for example, sound. Have you ever made a echo program that opens your microphone and sends audio to your headphones? It takes work, actually. But the point is, you do that ideally without using too many dependencies, or even better, any dependency at all. So the point is that you do the actual work to make this stuff happen. And that also teaches you a lot. So this is suggestion number 2. Find a project that you've never done before. And that not only that you've never done before, but also that you couldn't do before, or at least not well. Problem number 3, suggestion number 3, join Zig community. Check also this out. I mean, it was also in the talk, right? But there's also zig.day, of course. to participate to a Zig Day, so I'm not going to repeat that too much. But you can go to zigland.org. There's join a community, and join a community here so you can chat with other people doing this stuff. I also have a Discord server if you're interested. It should be linked in Twitch. And we chat about doing stuff with Zig. People like also to complain about software that they don't like, but it's mostly chatting about doing stuff with Zig. So I can't do or else. I guess I want to do this dot question mark, and then I want to do if built-in dot debug. Well, runtime safety. Yeah. If std debug runtime safety, then we say this: if add field lengths field dot name is null, then we panic. Okay. Can I get your opinion on maybe a stupid question about Zig? Sure. Okay, so we have also something that complains. Now that we're going to have to pass IO along with allocators, wouldn't it make more sense for Zig if Zig had like a context or maybe side effect type or something to bundle up all the stuff that's outside the program's control, like memory, IO, and all that? You will not be passing IO everywhere. The reader and writer interfaces, when you create them, they will bundle the reference to the IO context. So you will have plenty of places where, like parsers, for example, where they want to concern themselves with processing a stream of bytes. So they will accept a reader, for example, that they will read from, and a writer that they will write to. Think of like decompression, for example. You read compressed data, you output decompressed data, or I don't know, vice versa, depending on what you're looking at or what you're doing. So these things will not need a reference to IO specifically, because all they will be doing is read from a stream and write to a stream. And this concept of a stream usually is connected to real IO, but it doesn't have to. You can also have, a parser like this can also parse a piece of in-memory data. And the idea is that you create a reader that reads from an in-memory slice. And so you have one parser that basically you can use both for in-memory and for actual streams. So where am I going with this? Well, so basically these your parsers will kinda, depending on how you squint, you can consider them to be like sans IO. I don't know if you ever heard this term, but this used to be all the rage. Sans IO parser. To parser. I finally wrote a sans IO. I don't know, like this is an idea. I'll be honest, I'm not even convinced this is necessarily the smartest way to think about parsers. So I don't want to sell you on the idea that sans IO is this obviously good idea. I actually do not know, but it's a thing that people used to talk about. So the parsers then will accept a reader or a writer, and whether that intertwines with concrete IO or not, it's not their concern. So long story short, yeah, you will be passing IO around. Not a ton, not everywhere. Actually, you know what? Maybe yes, a ton. I guess it depends on how you structure your program, but not everywhere. And not everywhere that you pass IO will have an allocator. So I'm not necessarily against the idea of a context type, but by the way, in your program you can create it if you want. Like if you don't like the idea of of moving around two arguments every single time, make a context argument that you pass around in your code. Zig will probably never prescribe this to the ecosystem. Also because it makes you, it tempts you into passing IO also to places where the thing doesn't need IO. And same with allocator. So there's value in being able to look at a function signature and immediately be able to say, to have a reasonable read on whether that function will want to do allocation or not, explicit IO control or not. It might still do IO through a reader or a writer, so you need to also to be on the lookout for those things. But it's but if it accepts IO, it means that it really wants to do either like IO printing, like printing to standard output, standard error. Actually, no, you know what? Even then, it's not necessarily the case because you might still want to pass around standard out and standard error as readers and writers if you want to. I guess the one reason why you really need to accept IO necessarily is if you want to do IO.async, like if you want to manually manage scheduling around IO. I don't know. So I wouldn't worry too much. I think it should be fine. Expected integer or vector found optional U1. That is through 184. We basically need to do this. Actually, no, because here we can do dot question mark. Okay, so here we expect everything to be not null and present. It kind of sucks though that we're making this. We could actually create two types. One that is mandatory lengths and then optional lengths. And we only give optionalness to optional lengths. Yeah, you know what? Let's get rid of all this stuff. Let's make mandatory lengths and optional lengths. One last thing, will SED print change? No, it will stay the same as SED debug print. That will stay the same. As far as I know so far. So like this was definitely considered. I cannot promise it will stay that way forever, but so far it seems that SED debug print will still be SED debug print. Like some lengths, all lengths. So create once all lengths. Well, you know what? Let's just call it lengths, I guess. Okay. And then some lengths. Some lengths is the optional stuff. This one instead makes this not optional. There is no default value pointer, so null. And this is all t. Okay. So this is lengths. This is some lengths. This one's lengths. And then we have resize that has some lengths. You can omit lengths that you intend to leave untouched. Okay, and the way it works is that now with new lengths, we do linfo new lengths struct. Well, you know what? This is not necessary anymore because we know that this is the case. Even here in create lengths, there's no way this is not a struct. Actually, no, p could be a problem. Sorry, it's lengths that. Okay. Data, blah, blah, blah. And here we're doing if has field. But this is not if has field. This is like if it's not null. So it's like this. How do we restructure this? If at field new lengths field.name, and then we capture it as new field len. There we go, and then else. Well, and that, so this goes in here, and this goes here. Typo this, and then the problem is new field len. Yeah, it's like this. And then we need to int cast it. We can make it usize. There we go. Okay, so this is it gets complicated, but this is actually a good change. I'm happy with this. This is good stuff. We're doing good stuff. This is good stuff. Okay, so resize takes it some lengths. Expected U30 found U size. This is good, actually. Holy shit. Yeah, look at this. Oh, God. We got it. We got so much type safety now, 43. So here we're saying bytes is U size. But it can't be U size. Bytes needs to be a U30. Yep. And the flex resize is bytes to the land. Yeah, but we int cast it. Please tell me you can int cast it. Please tell me you're not gonna poop yourself. Okay, it didn't. Let's go. Okay, so it seems that we're doing good. Now we're not clobbering our own stuff anymore. So we're making a lot of progress, and then we're trying to add onion. So we add, I think, onion tare once. Where is it? Yeah, we added the first time, which causes us to mutate the tree. Then we try to add it the second time. This second time, we expect this to be an immediate match, but we got a unexpected result. Oh, because we this is the test that is wrong. 519. The second time that we add this thing, we expect it to have found it existing, and we test its value. And the value fails because, yeah, we set it to 1010, and here we were expecting the wrong value. Everything works. Everything works. Not bad at all. Not bad at all. this abstraction is doing work, a lot of work. And it actually got better. Like this last change truly made it better. And it provides us with so much type safety that we didn't have before. Like you saw these last errors that I got, they were delightful because they were telling me, look, I know via content reflection that this field only supports lengths up to U30. So you can't give me a usize length, well, unknowingly. You need to understand that this is the case. Previously, by having new lengths be any type, you could plop whatever number you wanted in there. And I guess we could maybe complain downstream, but we can only complain if at runtime we end up finding basically what happens is that there is a number that doesn't fit. And so the incast will blow up. But with this, we surface this information, like this restriction, this constraint, through the type system much earlier at the user level. So the user will immediately be notified when they try to do something wrong. Maybe they will int cast anyway, so it's up to them. But yeah, this is delightful. And everything works. We solved our clobbering problem. So really happy with this. And I think this is really it for today. It's been a cool 8 hours and 35 minutes stream. So I think, it's been a full day. I checked in a full 8-hour day with half an hour of lunch break. So what can I say? This was good. Tomorrow we implement node removal. We complete the insertion algorithm, and then we will be left with searching. Searching is huge. That there is a ton of logic in searching because it's important. Like searching in a Radix tree, it's obviously important. So yeah, and I think that the CPI will need to be readapted a bunch. But we made a ton of progress. Wow, I'm actually blown away by how well this whole thing is coming together. I wasn't immediately convinced right away that the ZigFlex abstraction would pull its weight, but it is, and this way of managing these lengths is reasonable. So out there, maybe there's gonna be situations where you need to do something completely crazy and this is not going to be a good fit for you. But so far, this seems reusable enough that it can be reused also for the things that aren't just ZigFlex. This reminds me that I have a cuckoo filter implementation that has needs similar to this. So maybe this is something that we also could give a look afterwards. It's called Zig Cuckoo Filter. I have it on GitHub. In any case, let's see what people are doing. Actually, you know what? I don't really care about that as much as let's see what the people doing Zig are doing. So let's raid one of them. Will you compare the memory overhead of Zig and the C version? Yes, we could. Although you know that it's supposedly going to be the same. I'm doing the same. Well, I've taken one creative liberty with how I structure things. But other than that, but will it be? That's obviously a fair question. Let me put it this way. If it's not more than a performance problem, it's a correctness problem. If it's not the same or like the same with a small delta based on the one difference that they made, then I fucked something up. Plain and simple, I fucked something up. Okay, so let's raid somebody doing Zig. Go say hi for me and enjoy some less weirdly complicated metaprogrammy memory alignment-y Zig. Enjoy.